So, you know, in a scalar matrix, all diagonal elements equal and non-diagonal elements zeros. In scalar matrix, diagonal elements equal. Therefore, x plus 2 is equal to 4. This gives x is equal to 2. And non-diagonal elements. Non-diagonal elements are zeros. Therefore, y minus 3 is equal to 0. This gives y is equal to 3. So, find the value of x and y if this matrix is a scalar matrix. So, to find the values of x and y, use the conditions involved in a scalar matrix. In scalar matrix, all diagonal elements equal. That's why x plus 2 is equal to 4, x is equal to 2. And the non-diagonal element zeros, already here is 0. So this must be 0. That's why y minus 3 is equal to 0. That is y is equal to 3. Bold is not.
Sir, due to shining, sir.
Due to shining. Okay. Is it clear?
Yes, sir, it is clear.
Yes. Okay. Let us continue. So this example based on symmetric matrix and skew symmetric matrix. Oh, already that fact scalar, diagonal, all varieties covered. Last two varieties in that symmetric matrix. Symmetric matrix. So once again, a square matrix is said to be symmetric matrix if transpose of the given matrix is the matrix itself. I mean, see, so to define the symmetric matrix, we use the definition of transpose of the matrix. So a square matrix, capital A, is said to be a symmetric matrix. A square matrix, capital A, is said to be a symmetric matrix if A dash is equal to A. That is, transpose of A is equal to the matrix itself only. So A is equal to, I take this, 4, 3, 3, 1. See, A dash transpose matrix of A is A dash. Transpose matrix of A is just interchange and rows and columns here. So we get like this. First row 4, 3, it becomes 4, 3 first column. Second row 3, 1, right 3, 1. Here A dash is equal to A. Therefore, A is symmetric. So the variety of the matrix, symmetric matrix, is a square matrix A. Basically, A must be a square matrix. So, a square matrix A is said to be a symmetric matrix if transpose of A is equal to capital A itself. Transpose of A is equal to capital A itself. So, I think clear now? Next one, skew symmetric variety. In that case, once again, A must be a square matrix. After that, A dash is equal to minus A. In case of skew symmetric, A dash is equal to minus A. Next variety, skew symmetric matrix. Skew symmetric matrix. A square matrix capital A is said to be a skew symmetric matrix. Skew symmetric matrix if A dash is equal to minus A. A dash is equal to minus A. Or A dash plus A is equal to 0 and not 0, it is null matrix. So that. So example, A is equal to, see, in this matrix, along diagonal we get 0 here because transpose of A and addition of transpose of A and A use null matrix 0 0, no, that. So along this we get 0 0 here, and suppose T is here, then in case of skew symmetric we get minus 3. Skew symmetric matrix. Here A dash is equal to transpose of 0 3 minus 3 0. It's a transpose. I mean, A dash is equal to 0 3 in first column, minus 3 0 in second column. So A dash is equal to, take minus 1 common, minus 1 inside, 0 3 minus 3 0 is equal to. So A dash is equal to, what happens here, minus 1 into the matrix A itself. Therefore, A dash is equal to minus A. In skew symmetric matrix, all diagonal elements zeros, and on either side of diagonal are of opposite sign. It's equal to skew symmetric. I hope it's clear now. Symmetric and skew symmetric example.
Sir,
The definitions of these two. Yes, yes. Clear now? A is equal to, in brief, Aij is equal to Aji. That is, A dash is equal to minus Aji, and Aij is equal to 0. So one can define in the notation Aij is equal to Agi. Second one, for symmetric, Aij is equal to Agi, and for skew symmetric, Aij is equal to minus Agi for all I not equal to j. That is, elements on either side are of opposite side, and diagonal elements zeros. So tell me, what's the variety for this here? 3, 3, 1, 1, 4, 4, 6, 7, 8. See, this one is example for
Sir, ಸ್ವಲ್ಪ blur ಇದೆ sir.
blur ಇದೆನಾ? Yes. See, are these 2 points clear now? A square matrix A is equal to Aij is symmetric if Aij is equal to Aj. Elements on either side equal. I mean here Aij is equal to Aji. That is, A dash is equal to A. So A is symmetric. And I take B here.
Sir,
Yes,
board is not clear, sir.
board is not clear. I think it's on. Is it shining or not? Blur.
Blur, sir.
Blur. Wait. So I think it's problem of blur. Anyhow, I repeat the entries here. Symmetric A, along diagonal 6, 7, 8, and on either side of same term 3, 3, 1, 1, 4, 4. I mean Aij is equal to Aji. Aij is equal to Aji. That is, A dash is equal to A. So first one is example for symmetric. So second one for skew symmetric. B or take A itself, nothing happens. A is equal to, so here Aij is equal to minus Aji for all I different from J. So this condition gives, if I write 3, then what should be here? If it is 3, then here the element 3, Aij is 0 for all I is equal to j. I mean A11 is 0, A22 is 0, A33 is 0. All diagonal elements zeros, and non-diagonal elements on either side of this are of opposite sign. If it is 3, then I must get minus 3. If it is 5, if it is minus 5, then we must have minus 5 here. If it is 6, then we must have minus 6. No, like this. So these two examples for symmetric and non-symmetric matrices.
Sir, board is not clear, sir.
Board is see, is it changing or that clear into the change आता आगे देना ठीक है. First column, third element, yes. See, if I write -3, -5, I must write +5 here. Or if I write -5 here, +5. So, this to fulfill this condition, out of these two, one must be negative, one must be positive. So, I take preferably this thing. Now, -3, -5, +5. 3, -3, -6, 6. So, like this. Next, take algebra of matrices. Algebra of matrices. So in this case, I take two matrices. Let capital E is equal to, see, I take A, B, C, D, and capital B is equal to X, Y, Z, W. A and B,
Sir,
B2, yes.
sir, at first line, what are you written, sir?
First line, first line
Sir,
algebra. Yes. First line algebra of matrices. First line algebra of matrices. Addition of the matrices, multiplication. So study first line algebra of matrices. So particular take two matrices of same order. A is equal to A, B, C, D, X, Y, Z, W. A and B, B2 matrices of same order. Same orders 2 by 2. Then, first point, for some constant K into A is equal to C. For some constant K constant means some number. K into A. Here K, A is A, B, C, D. In this case, distribute this to K to all elements of this matrix. That is, here, first row, K A, K B, K C, K D. Clear? So, in case of matrix, distribute K to all elements of the matrix. All elements of the matrix. K A, K B, K C, K D. And at the same time, see, in case of determinant, this thing not happens. In case of determinant, K into this, we should not distribute K to all these elements here. K should be multiplied to all elements of any one row or any one column. So, see, it is due to the property of determinant here. K into, we get in case of matrix, K into all elements here. K A, K B, K C, K D like this. Whereas in case of determinant, this we say, we said K to all elements of this or all elements of this or all elements of first row or all elements of second row. No? Like this. This happens in case of determinant. So in case of matrix, we get like this. And the second point, A plus B. Addition of two matrices. The addition of the matrix B to the matrix A, once again a matrix in which all elements of B are added to the corresponding elements of A. I mean, A is here, A, B, C, D, and B is X, Y, Z, W. Add elements of these to the corresponding elements of first. So we get like this: A plus X, B, here C, then D, B plus Y, C plus Z, D plus W. So from this we say the sum of two matrices is again a matrix obtained by adding all elements of the second matrix to the corresponding elements of first matrix. See once again, the addition of two matrices defined only when they are of same order. Orders must be same. See, order of A is 2 cross 2, order of B is also 2 cross 2. So one can add B to A by adding all elements of B to the corresponding elements of A. A plus B, ಬೇಕಾದ್ರೆ B entries A entries corresponding entry of A add ಮಾಡಬೇಕು. A plus X, B plus Y, B plus Z. Third one, see on the same line A minus B. So once again, A is A, B, C, D minus X, Y, Z, W is equal to A minus B is subtract all elements of B from the corresponding elements of A. Subtract all elements of these from the corresponding elements of first matrix. That is, X should be subtracted from A, subtract B from B, Y from B, Z from C, W from D. I mean, A, B, C, D, elements of first, minus these. I mean, minus X, minus Y, minus Z, minus W. Elements of A, add all elements of B to the corresponding elements of A. A minus B means subtract all elements of B from the is A, order of A 2 cross 2, order of B 2 cross 2, B is X, Y, matrix multiplication the lag is around. These column elements ಈ ತರ distributed ಆಗ್ತದೆ. second. See, this condition must be fulfilled this side. Number of columns of first is equal to number of rows of second, and after that we get this in this way combination. So that is A into B.
Sir, board is not clear.
Board is not clear. So
Sir, writing is blurred, sir.
blur. See, I
Yes,
don't.
sir.
No, sir.
Is this question clear?
Yes, sir. Yes, sir.
Yes, sir.
Here clear? No? Huh?
Yes, sir.
Yes. Then I'll write here also. I repeat the same thing here. See, I repeat the same here. I write the same here. The first point A 2 cross 2, E 2 cross 2. A is A, B, C, D. A is A, B, C, D. And B is X, Y, Z, W. X, Y, Z, W. See, A cross B, 2 cross 2, 2 cross 2. Number of columns of first. Number of columns of first be equal to number of rows of second. See, ಇಷ್ಟು ಗೊತ್ತಾರ ಸಾಕು ಫಸ್ಟ್ಗೆ. These two ಇಲ್ಲಿ ಇದೆ ನೋಡಿ. ಹೀಗಿರೋದು ಈ ತರ ಬಿಟ್ಸುಟ್ ಆಗ್ತಾ ಹೋಗ್ತಲ್ಲ. ಸೊ ಅದನ್ನ ಹೇಗೆ ಬರೀತೀವಿ ನೋಡಿ. 2 cross 2 into 2 cross 2. These two equal ಇದೆ. Then we get a matrix of this. So at last A into B, we get a matrix of order 2 cross 2. 2 rows, 2 columns. So the way of combination is, I say use all these elements. See, for the easy way to understand the concept is like this. I say use all elements of these. Use means A, I write something gap, plus B something gap, second row C some gap, plus D some gap. See, I say use all elements of first matrix, means A gap plus B gap, C something plus D something, and write the same, repeat the same by counting the number of columns of second. So each gap is 2 columns in there. So repeat the same 2 times. Is it clear? Use all elements of this means write in this arrangement, and repeat this type of arrangement by counting the number of columns of second. Second matrix contains 2 columns, so repeat the same thing in this way. A gap plus B gap, C gap plus D gap. Then in these gaps, insert first column elements in first gaps, second column elements in second gap. XZ is insert like this. X is here and Z is here. XZ. Good. So, yeah. Second one is second gap here. YZ, second column element. YZ. Insert YZ in second column gaps. YZ here like this. Here Y, Z, Z. So this is nothing but AX plus BY, A cross B, A into B. AX plus BZ, AX plus BZ, CX plus DZ. So insert in this way. So it is just like CA A, B, see this one is your A, this one is B, and here A B. Yes, A, B, C, D, X, Y,
Sir,
Z, W. C. A
sir,
is to, yes, these two.
sir, D is W, sir, Z dot.
A, B, C, D, A, W. Y, W,
D of W, sir.
Y, W. Y, W. AX plus BY. AX plus BY is here. Next, CX plus DY. CX plus DY. Next, AY plus BW. AY plus BW. AY plus BW. And next, CY plus DW. No, right here. CY plus DW. This type.
Sir,
A.
sir,
So to, yes.
sir, first box X, Y, Z, W, sir.
X, XY, uh, ZW. Then AZ, no, AX plus BY is here. CX plus DY is here. No. Next further for these elements. AZ, not Y. AZ plus BW. No. AZ, see, AB, we write A, left this side, we write B, and here AB. So I'll get, or simply it's the way of combination of two, A into B is like this. So very simple. In first one, gap like this. In second column, insert in this way. So I'll explain in detail while taking the different examples.
Sir, sir,
Yes,
sir, sir, once again explain AB, sir.
AB, product of these two,
Ha, sir.
same or that is shortcut way. Shortcut way. Shortcut way means I'll explain once again the same thing, and I take maximum number of examples. Don't worry. No,
Yes,
I'll
sir.
take more to convince the concept. I'll take different varieties of examples. The time being that A is equal to B is equal to A is first, B is here. Basic condition: the number of columns of first must be equal to the number of rows of second. So that condition must be fulfilled to define AB. No? Yes. See, clear? Well, next, try to solve this example. A is equal to find out this thing. 4, 3, 2, minus 1. Find A plus A dash. Second, A minus A dash. A plus A dash. A minus A dash. A is equal to 4, 3, 2, minus 1. Find A plus A dash and A minus A dash. So A plus A dash, A is 4, 3, 2, minus 1 plus See, dash is transpose of A. So it is in this way 4, 3, 2, minus 1. A dash. Interchange rows and columns of A. So this is equal to 4 plus 4, 3 plus 2, 2 plus 3, minus 1 plus minus 1 is equal to 8, 5, 5, 0. So in this case, on either side, same. A plus A dash is equal to this is symmetric matrix. Symmetric matrix. Therefore, for any square matrix, A plus A dash is symmetric. A plus A dash is symmetric. A is equal to 4, 3, 2, minus 1. Find these two. And for the solution of first, once again, A plus A dash, solution of A plus A dash gives a square matrix in which on either side elements are same. It is symmetric type, symmetric matrix.
Sir, sir, minus 1, minus 2 ಆಗುತ್ತೆ ಸರ್ ಅದು.
0 ಬರ್ದಿರಲ್ರಿ ಅದು 0 ಬರ್ದಿದ್ದು
minus 1 ಸರ್, plus 1 ಅಲ್ಲ ಸರ್.
No, sir, it is correct.
Next, find A minus A dash. Find out A minus A dash and see the nature of A minus A dash here.
Sir, your video is stuck.
Sir, no audio, sir. No audio.
Yes. Yes. Are you listening?
Yes, sir.
Yes. See, for this particular 2 cross 2 ordered matrix, it's clear A plus A dash is equal to, I mean A plus A dash gives a symmetric matrix, and A minus A dash gives a skew symmetric matrix. Skew symmetric matrix. See, this minus of minus 1, correct? Minus of minus 1 is plus 1, its value is 0. This one, A minus A dash is an example. In this case, A minus A dash gives a matrix of skew symmetric variety because all diagonal elements zeros and the non-diagonal elements are of opposite sign. One side positive, other side negative. So this type. A is equal to, see, I tried 1 by 2 outside. Inside, A plus A dash plus A minus A dash.
ಸರ್
A plus S.
ಕೆಳಗಿನ -2 ಆಗಲ್ರಿ ಸರ್ ಅದು
ಯಾವ್ದಮ್ಮ ಇದು?
ಕೆಳಗಿನ ಸರ್. ಹಾ ಸರ್.
ಇಲ್ಲ, ಇಲ್ಲೇನಿದೆ ಮೈನಸ್ ಆಫ್ ಮೈನಸ್ ಪ್ಲಸ್ ಆಯ್ತು. -1 + 1 ಅದು 0 ಆಗ್ತದೆ. ಆಮೇಲೆ ಇನ್ ಕೇಸ್ ಇಲ್ಲಿ -2 ಆದ್ಮೇಲೆ ಏನಾಗ್ತಿತ್ತು? ಸ್ಕ್ಯೂ ಸಿಮೆಟ್ರಿಕ್ ಆಗೋದಿಲ್ಲ. ಇನ್ ಕೇಸ್ ಆಫ್ ಸ್ಕ್ಯೂ ಸಿಮೆಟ್ರಿಕ್ ನಲ್ಲಿ ಏನಿರ್ಬೇಕು? ಆಲ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಜೀರೋಸ್ ಇರಬೇಕು. 0 ಆಗ್ತದಿಲ್ಲ. -1 + 1 0 ಆಗ್ತದಿಲ್ಲ. 0 + 0 0 0 and on either side of principal diagonal opposite sign. 3 - 2 is 1, 2 - 3 is -1. Clear? Next. So in ಮೇಲ್ಗಡೆ A is equal to 1 by 2 A plus A dash plus A minus A dash. See, A dash into 2A divided by 2. 2 cancels. So you'll get A only. So next, A is equal to, I write 1 by 2 into 1 by 2 into A plus A dash plus 1 by 2 into A minus A dash. So if you take A is given square matrix, is equal to, what about A plus A dash here? No. Avagla example noted, previous example. For any square matrix, A plus A dash is always symmetric matrix. A minus A dash is always skew symmetric matrix. So given square matrix is A and this is symmetric matrix. Plus 1 by 2 into skew, whatever, 1 by 2 into this is again the skew symmetric matrix. So given square matrix A can be expressed as sum of the symmetric and a skew symmetric matrix in this way. Given matrix, so the A is equal to B plus C type. B plus B is half A plus A dash is symmetric one. And C is half A minus A dash, that is skew symmetric. So given matrix, whatever the given square matrix A can be expressed as the sum of two matrices in which first one is symmetric one and second one is skew symmetric one. So one can split the given square matrix in terms of sum of a symmetric and a skew symmetric matrices. So this is
Sir, first line in, sir.
first line, no? First line.
Yes, sir.
See, ಇಲ್ಲಿ ಏನ್ ಬರ್ದಿಲ್ಲ as ಅಂತ ಅಥವಾ ಇಲ್ಲಿ ನೋಡ್ರಿ ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೇನೆ ನಾ ಕನ್ಸಿಡರ್ ಅಂತ ಬರೀತೇನೆ ಕನ್ಸಿಡರ್ ತಗೊಂಡೆ ನೋಡ್ರಿ ಅಂದ್ರೆ ಏನಿದೆ ಎ ಪ್ಲಸ್ ಎ ಡ್ಯಾಶ್ ಪ್ಲಸ್ ಎ ಮೈನಸ್ ಎ ಡ್ಯಾಶ್ ಏನಾಯ್ತು ಎ ಪ್ಲಸ್ ಎ ಡ್ಯಾಶ್ ಎ ಮೈನಸ್ ಎ ಡ್ಯಾಶ್ ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು ಎ ಪ್ಲಸ್ ಎ ಏನಾಯ್ತು ಅಂತ 2a. Consider a is equal to 1 by 2. See, 1 by 2 into I write 2a and ಬರೀತೇನೆ ನೋಡಿ ಕ್ಲಿಯರ್ ಆಗ್ಬೋದು. Consider a is equal to 1 by 2 into 2a. 2a ಇದ್ದದ್ದು a and this a split ಆಯ್ತು. ಇಲ್ಲೇನಿದೆ a ನೋಡಿ ಇಷ್ಟು ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. a is equal to 1 by 2 into 2a. 2 ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು ಏನೇ ಇದೆ a is equal to a ಆಯ್ತು. Then 1 by 2 ಇದೆ ಇಲ್ಲಿ a 2a ಇದ್ದದ್ದು a plus a ಅಂತ ಮಾಡಿದೆ a dash minus a dash ಇದ್ದದ್ದು ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬಿಡುತ್ತೆ ಅಷ್ಟೇ. ಇದು ಅಡಿಷನಲ್ ನ ತಗೊಂಡೇನೆ ಅಷ್ಟೇ. ಅಂದ್ಮೇಲೆ a plus a dash plus a minus a dash is a. So, but we know a plus a dash is a symmetric matrix. A minus a dash is a skew symmetric matrix. So, given square matrix is splitted in terms of symmetric matrix, the sum of a symmetric and a skew symmetric matrix. So, ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ರೆ ನೀವೇ ಟ್ರೈ ಮಾಡ್ರಿ. ಫಸ್ಟ್ ರೋದಲ್ಲಿ 1 2, ಸೆಕೆಂಡ್ ರೋದಲ್ಲಿ 3 4 ಅಂತ ತಗೊಂಡ್ರೆ, ಫಸ್ಟ್ ರೋದಲ್ಲಿ 1 2 ತಗೊಂಡ್ರೆ, ಸೆಕೆಂಡ್ ರೋದಲ್ಲಿ 3 4 ಅಂತ ತಗೊಂಡ್ರೆ, then express A in terms of sum of symmetric and a skew symmetric matrix. Example, express A is equal to 1 2 3 4. Express A is equal to 1 2 3 1 2 3 4 as the sum of a symmetric and a skew symmetric matrix. As the sum of symmetric and skew symmetric matrix. Say express A 1 2 3 4 as the sum of symmetric and a skew symmetric matrix. So use the same concept here, this concept, and symmetric matrix 1 by 2 into A plus A dash, 1 by 2 A minus A dash. See, you may get for 3 marks example. No? For 3 marks, express this as the sum of symmetric and skew symmetric matrix. Now, B is equal to 1 by 2 A plus A dash. It is 1 by 2 is 1, 2, 3, 4. 1, 2, 3, 4. A. And A dash is A dash is like this. 1, 1 plus 1, 3 plus 2, 4 plus 4. Three plus 3 is 5 by 2. 4 plus B is equal to
Sir, video is stuck, sir.
C is equal to 1 by 2. That is 1 by 2. A minus A dash is, I write directly 1 minus 1. Two, 3, 4, 2, 4. 1 by 2 1 by 2 inside 0 minus 1 1 0. That is 0 minus 1 by 2 1 by 2 0. C. A is equal to B plus C. A is equal to B plus C. That is A is 1, 2, 3, 4. B is equal to say 2 by 2. Further we can write 1. That is B is equal to what? 1 5 by 2 5 by 2 4. So B is 1 5 by 2
Sir,
5 by 2 4.
sir,
Yes.
I can't understand, sir, first step.
For this for
Yeah,
B is
sir.
equal to say in note I explained that A is equal to what? A is equal to 1 by 2 into A plus A dash. Previous course ಅಲ್ಲಿ ಏನು ಬರ್ಕೊಂಡ್ರಿ ಮೇಲೆ A is equal to ಏನು ಮಾಡಿದ್ರೆ A is equal to B plus C ಏನು ಬರ್ತಾರೆ A is equal to B plus C. That is A is equal to B plus C means 1 by 2 into what? A plus A dash plus 1 by 2 into A minus A dash. Is it clear? A is
Yes,
equal
sir.
to A plus B plus C. A is equal to B plus C. Oh, A given is B plus C find out ಮಾಡಬೇಕು.
Here,
B
what
ಅಂದ್ರೆ
are you
ಏನಿದೆ
taking, sir?
1 by Yes.
K is equal to what, sir?
What are you?
K. Here,
A
K.
is where is K? There is no. See, A plus A. See, question is what? Express A in terms of sum of a symmetric and a skew symmetric matrix. X plus A like B plus C, where B is symmetric, C is skew symmetric. And the nature of symmetric is 1 by 20 A plus A dash. If A is any metric, then 1 A plus A dash is symmetric one. And A is any square matrix, then A minus A dash is equal to A minus A dash is what? Skew symmetric one. So A plus A dash is symmetric, A minus A dash is skew symmetric. So to split A in terms of a symmetric as well as a skew symmetric matrix, first X plus B is equal to what? Like B is equal to 1 by 20 A plus A dash. What is A? A is given matrix. A dash is its transpose. Sum of these two yield B. So B is equal to C. In B, the elements on either side same. So that is symmetric matrix. And then C is 1 by 2 into A minus A dash. That is 1 by 2 into A minus A dash is, we get a matrix of this kind. C is equal to what? Diagonal element zeros, and on either side negative opposite sign. Minus 1 by 2, 1 by 2.
Sir, here B is equal to
Symmetric matrix. B is equal to what? 2 by 2. That is 1. 2 by 2.
5 by 5 by 2 and
B plus. See, divide all terms by 2. 2 by 2. 5 by 2. No, K is 1 by 2. See, I think your doubt is K. See, this is nothing but K. No, divide all terms by 2. 3 plus 2 is 5. 5 by 2. Here, 8 by 2. No, like this. That is 1, 5 by 2, 5 by 2, 4. B, it's an example for symmetric matrix because on either side, entry same, symmetric. Well, next take C. C is equal to 1 by 2 into A plus A minus A dash. See, for our convenience, instead of writing this, we write B. What I said? See, B, 1 by 2 A plus A dash, skew symmetric symmetric antide. Idu skew symmetric ide. Symmetric for time being, for our convenience, we write B. And for instead of this, we write C. So our main aim is to split the given matrix A in terms of a symmetric B plus a skew symmetric C. I think it's clear now. A is equal to B plus
A
C.
equal to B plus C ತಳಗಿಂದ ಏನದರಿ
ಇದು A is equal to B plus C ಅಂತ ಬರ್ತಾರೆ.
Sir, last line.
A is equal to B. Last line ಅಂದ್ರೆ A is equal to B plus C ಅಂತ ಬರ್ದ್ಮೇಲೆ B ದ ಬದಲಿನ ಏನು ಬರ್ದೆ 1 by 2 into A plus A dash. ಅಂದ್ರೆ 1 by 2 into A plus A dash ಅಂತ ಅನ್ನೋದು ಬ್ರೀಫ್ ಆಗಿ ನಾವು ಕನ್ವೀನಿಯಂಟ್ ಆಗಲ್ಲ B ಅಂತ ಬರೋದು ಅಷ್ಟೇ. ಇದನ್ನು B ಅಂತ ಬರೋದು ಇಲ್ಲ. Then C is equal to 1 by 2 A minus A dash ಇದೆ. 1 by 2 A minus A dash. A minus A dash is equal to difference of matrix ಆಯ್ತು. And 1 by 2 into ಯಾವ ತರ ಆಯ್ತು? Diagonal 0 0 non diagonal opposite type here. So ಇಲ್ಲಿ A plus B plus C ಅಂದ್ರೆ A is equal to ಏನಾಗ್ತೀವಿ ಹೇಳ್ರಿ ಈಗ F is B is 1 5 by 2 5 by 2 4. Next B C ಇದ್ದಲ್ಲಿ ಬರೀಬೇಕು ನಾವು ಅಷ್ಟೇ. What is C? 0 minus 1 by 2 1 by 2 0. ಏನಾಯ್ತು? ಸೊ ಇದೇನಾಯ್ತು ನಿಮ್ದೀಗ given square matrix A is equal to given square matrix A is equal to symmetric B plus skew symmetric C. Given square matrix is expressed in terms of symmetric and skew symmetric. So don't worry, I'll repeat. I'll explain the same thing by taking you more examples tomorrow. I explain everything once again in tomorrow. Yes. See, I think time is over. Can we conclude? See, I conclude the class. I think. Thank you. Thank you. Thank you.
Okay, good morning, students.
Good morning, sir.
Yes, please mute your mic. So, in the last class, we have discussed about the regarding isolation of one is copper, another one is a zinc, isn't it? So, right now in this class, we will move toward the next bit of your topic, that is electrochemical principle involved in a metallurgy. Electrochemical principle involved in a metallurgy. So far we have studied the pyrometallurgy. You are very familiar with the pyrometallurgy. Now it will be for the pyrometallurgy, thermodynamic principle will be applicable. Similarly, for the reduction of the metal ions in a solution or in terms of their molten state, here the electrolysis, what we are saying here, the electrochemical principle. Upon electrolysis or by adding the some reducing elements, we can also extract the metal. So that we are going to study in this part right now. Okay. Molten metal salt electrolysis will be done. Okay. Rahul Navi, and somehow you are please mute your mic first. Somehow the disturbance is there. Yes, Rahul Navi. Okay, thank you. Yeah. So for this reduction of this molten metal salt, electrolysis will be done. Try to understand my point. Molten metal salts can be doing the electrolysis. Okay. Such a method is based upon the electrochemical principle. So in last year only, we have studied the one equation. Electrochemical principle means in the sense how it will be, and all the things which will be explaining, we have studied. Okay. If you go to this equation right now, delta G is equal to, okay, minus N E not F. So what is the meaning of this one? Where N is the number of electrons and E is the electrode potential of your redox coupling reaction, and F is a Faraday, and same again whatever the G stands for. What we have the G stands for? Yes.
Gives
What is
free
the
energy.
G stands for right now?
Gives free energy.
Yes, gives free energy. It will be explained by basis upon the principle, that is electrochemical principle. Similarly, what you have come across, more reactive metals have a large negative values of the electrode potential. So whatever this E is there, it has a large negative values. If it will be the more reactive metals, larger negative value of a E naught value. So that we call it as a electrode potential. So their reduction is difficult. So the reduction is difficult. So the difference of two E values corresponds to the positive E value, and consequently we are going to give here the delta G value will be going to give in terms of the negative. So then lesser negative metal will come out the solution and more reactive metal will go out the solution. Okay, so this is how the concept. Okay, if you have taken here the simple example, copper plus 2 is react with your iron. Of course, these reactions will be get carried out in terms of their aqueous medium only. Okay, so what you are going, you here the copper plus iron ion. It is in terms of the aqueous solution. Okay, so here it is a solid and here it is a solid. So what the indication is denoted by from this reaction? Copper ಏನಾಗ್ಲಿಕತ್ತದ, what copper one thing, and next one is the iron. What about the copper and what about the iron right now? ಏನಂತ ಹೇಳ್ತಾ ಇದೀವಿಲ್ಲಪ್ಪ ಅಂತಂದ್ರೆ ನಾವು, yes, iron is in terms of the in a reactant side it is a solid, and it's, if you come to point of the product it will become a aqueous form. That's what we call it as a ionic form. Okay, so what the thing we can come across from this reaction? ಏನಂತ ಹೇಳ್ತೀವಿ? The differences between two E values, copper du electrode potential ಮತ್ತೆ iron du electrode potential corresponds to the positive E value. The consequently the negative of delta G negative ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ನಿಮಗೆ ಗುರ್ತದ, is this reaction is spontaneous or non spontaneous? Reaction ಏನಾಗ್ತದ್ರಿ? What about the reaction? Yes, what about the reaction? If you go to in terms of the delta G, this will be in terms of the negative. Students, spontaneous ಆಗಿರ್ತದೋ ಅಥವಾ ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗಿರ್ತದೋ? Yes, delta G will be a negative means. Yes, it is.
Delta G minus ಇದ್ರೆ spontaneous ಆಗತ್ತೆ ಸರ್.
As it is a spontaneous. If it is a delta G will be a negative means in the sense it is a spontaneous. So if it is the negative delta G will be going to give means in the sense the main operation which will be depending upon here the this E naught value. This is what we call it as a electrode potential value. Number of N is a what we call it as a number of electrons, and F we call it as a Faraday. Okay, Faraday, you know, 96,500 coulombs. That's what we call it as a Faraday. That is a constant one. But the changing, that's what we call it completely how the Gibbs free energy change in terms of the thermodynamic principle, where the delta H is a mainly important right there. ಇಲ್ಲಿ ನಾವೇನಂತ ಬರಿತಿದ್ವಿ, ಇಲ್ಲಿ ಡೆಲ್ಟಾ ಹೆಚ್ ಅಂತ ಬರಿತಿದ್ವಿ. ಈ ಡೆಲ್ಟಾ ಹೆಚ್ಚು ಇಂಪಾರ್ಟೆಂಟ್ ಅದಂತ ಹೇಳ್ತಾ ಇದ್ವಿ ನಾವು. Similarly here what we call it as a electrode potential. ಈ electrode potential main important too. ಅಂದ್ರೆ differences of the two different elements have a value corresponds to the positive E value, then consequently the whatever the negative delta G value, then less reactive metal will come out of the solution. Less reactive metal come out from the solution and more reactive metal will go into the solution. Simple electrolysis will be done here, whatever we are given in this equation. So this is how the reaction will be get carried out. So the discharge as negative electrode, that's what we call it as a cathode, and deposited there, and whatever the reactive metal produced in a suitable material using the electrode So like this is how the reaction will be carried out. ಇಲ್ಲಿ ನಿಮಗೆ ಈ ರಿಯಾಕ್ಷನ್ ದೊಳಗೆ ಗುರುತಾಗ್ತದೆ ನಿಮಗೆ ಯಾವುದು ಸೊಲ್ಯೂಷನ್ ಯಾವುದು more reactive ಅದ ಯಾವುದು less reactive ಅದ ಅಂತ ಹೇಳ್ತೀರಿ out of this copper and iron. Which one is a more reactive and which one is a less reactive? Lesser reactive will be a come out from the solution. Lesser reactive will be a come out from the solution, and more reactive will be a yes, metal will go into the solution. As compared to copper and iron, which one is a more reactive?
Copper, sir.
Yes, copper is a more reactive. Why? Because of it will be coming out from the solution. Try to understand my statement here.
Sir, iron is more reactive, sir.
Yes, iron is more reactive. ಏನಂತ ಹೇಳಿಗತ್ತೀನಿ statement understand ಮಾಡ್ಕೋರಿ. What I'm saying here, the less reactive metal solution will come out of a solution. Less reactive metal will come out of the solution and more reactive metal will go to the solution. Solution ಅಂತಂದ್ರೆ +2 ಫಾರ್ಮ್ ದಾಗಿರೋದು. +2 ಫಾರ್ಮ್ ದಾಗ ಈ ರಿಯಾಕ್ಷನ್ ದೊಳಗೆ +2 ಫಾರ್ಮ್ ದೊಳಗೆ ಏನ್ ಸೊಲ್ಯೂಷನ್ ಅದಲ್ಲ, ದಟ್ಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಸೊಲ್ಯೂಷನ್. ಅಕ್ವಿಯಸ್ ಅಂತ ಬರ್ದಿದ್ದದ. ಸಾಲಿಡ್ ಅಂತಂದ್ರೆ ಅಲ್ಲ ಅದು, ಇಟ್ಸ್ ಪ್ಯೂರ್ಲಿ ಮೆಟಲ್ ಅಂತ ಹೇಳ್ತಾ ಇರೋದು ಇಲ್ಲಿ. Less reactive metal will come out of the solution. Come out of the solution. Copper is a less reactive metal as compared to the iron. Yes. What is the answer? Kiran.
Yes, sir. Yes, sir.
Out of this copper and iron.
Yes, sir. Copper is less reactive.
Which one is ಐರನ್ ಸಾಲಿಡ್ ದಿಂದ ಅಕ್ವಿಯಸ್ ದೊಳಗ ಆಗ್ಲಿಕತ್ತದ, ಹೌದಾ? ಅದು ಸೊಲ್ಯೂಷನ್ ಒಳಗ ಹೊಂಟದ. ಸೊ ಐರನ್ ಈಸ್ ಮೋರ್ ರಿಯಾಕ್ಟಿವ್ ದ್ಯಾನ್ ಯುವರ್ ಕಾಪರ್. Iron is more reactive than your copper. So this is how the thing we can understand. Okay, so same principle all about all other things which will be applicable right now in terms of the next extraction. That is what we call it as a extraction of the aluminium. So most important bit in this chapter, that's what we call it as a extraction of aluminium. Hall Herold process anta karitivi idike. Hall Herold process for the extraction of the aluminium. Okay, so what is the metallurgy will be involved in this metallurgical principle which will be involved in this extraction, means in the sense, again I am saying here the what I have discussed right now, that is a electrochemical principle. Electrochemical principle. Molten salt solution ತಗೊಂಡು ನಾವು ಈ electrochemical principle ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಅವಾಗೆ ನಮಗೆ extraction of this aluminum can be explaining. Okay, so now in this extraction of aluminum, whatever the purified bauxite, known thing for you people, bauxite is a ore for the aluminum. Purified bauxite ore is taken off. Okay, what is the composition of that purified bauxite ore? What do you have the composition? Bauxite do formula in bartadri. What do you have the formula of that bauxite? Composition of the bauxite already have discussed. Exact ಆಗಬೇಕು. ಜಸ್ಟ್ ಕಾಮನ್ ಆಗಿ ಏನಂತ ಹೇಳ್ಬಿಡ್ತೀವಪ್ಪ ಅಂತಂದ್ರೆ ನಾವು ಬಾಕ್ಸೈಟ್ ಅನ್ನ Al2O3 ಅಂತ ಹೇಳ್ಬಿಡ್ತೀವಿ ನಾವು, ಹೌದಾ? Al2O3 ಅಂತ ಹೇಳ್ಬಿಡ್ತೀವಿ. ಸೊ ಬಟ್ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ನೀವು ಹೋದ್ರೆ what we have the bauxite composition right now, here it is AlO, what you are writing here the X, and here it is a OH 3 minus 2 X. So this is how, yes, correct Bhavna, what you are written. This is a Chi4 of aluminum. This is a Chi4. Bauxite is a Chi4. Apart from this, another one is there, that is what we call kernolite is there. It is from the clay. It is not a chief. That's why just you are for the extraction, this is the only what we are taking. Okay, so this is a what we are taking bauxite ore. Now for this, what you are taking apart from this one, electrolytical reduction of the pure alumina to aluminum, main heading. Electrolytic reduction of pure alumina. Pure alumina means in the sense that is what we call it as your bauxite ore. Pure alumina to aluminium. Ashwini Nayak, please mute your mic. Yes. So this is how the thing we can done. Andre ಅಲ್ಯೂಮಿನಾದಿಂದ ನಾವು ಅಲ್ಯೂಮಿನಿಯಂ ಅನ್ನ ಎಕ್ಸ್ಟ್ರಾಕ್ಷನ್ ಮಾಡ್ತೀವಿ. And complete overall process we call it as a Hall-Héroult process for your kind information. And the process we call it as a Hall-Héroult process. Hall-Héroult process for the extraction of aluminum anta ಹೇಳ್ತೀವಿ. Okay, this is a very important question, carries 3 mark in your annual examination. Okay, I hope so. It is a fourth question in 3 mark questions ಬರ್ತಾವಂತ ಹೇಳಿದ್ವಿ ನಾವು annual examination ಗೆ. ಅದರಲ್ಲೇ ಇದು 4th question ಕೌಂಟ್ ಮಾಡಿದಾಗ. ಓಕೆ, ಸೊ ಅಲ್ಯೂಮಿನಿಯಂ is extracted by the electrolysis of alumina dissolved in fused cryolite containing the little fluorspar. So what you have the cryolite and what you have the common agi ನಿಮಗೆ ಏನ್ ತಗೋತೀವಿ ನಾವು ಈಗ ಇಲ್ಲಿ ಅಲ್ಯೂಮಿನಾ. ಓಕೆ, ಫಸ್ಟ್ ಒನ್ ಇಸ್ what you are taking here the alumina. Okay, to this what you are adding, that is what I am saying here, the cryolite anta ಕರಿತೀವಿ. having the formula Na3S. very good Bhavna. Na3Al F6, it is a formula, cryolite formula. So this is cryolite, already you have studied in your first PUC in hydrogen chapter only. Cryolite, zeolite anta kaltir ನೀವು. Okay, so to this cryolite we are adding the little bit fluorspar, that is what we call it as a CaF2, having the formula CaF2. so alumina ಹಾಕ್ತೀವಿ. what you are taking alumina and another one is a cryolite and next one is a little fluorspar. So what about the alumina? Cryolite makes alumina as a good conductor. This is what we have, the cryolite. Okay, this cryolite makes alumina is a good conductor, one thing. And fluorspar, whatever the fluorspar lowers the melting point of this complete electrolyte. ಹೆಂಗೆ ಈಗ ಇಲ್ಲಿ ಹೇಳ್ಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ ನಿಮಗೀಗ ವಾಟ್ ಐ ಆಮ್ ಸೇಯಿಂಗ್ ಹಿಯರ್, ದ alumina main point, to this alumina we are adding the cryolite. Okay, we are adding the cryolite. So okay, so now cryolite, how it is a good conductor, which will be explained by what is having, it is having the formula is NaAlF6. okay, it will gives you 3 NaF and AlF3. this AlF3 will be right now next step. AlF3 gives you Al plus 3 in terms of the ionic form 3F minus. Okay, so whatever that aluminum is right now in terms of the molten form, ಅಲ್ಯೂಮಿನಿಯಾದಾಗಿಂದೇ ಅಲ್ಯೂಮಿನಿಯಂ ಇದ್ರ ಜೊತೆ ಕಾಂಬಿನೇಷನ್ ಆಗ್ತದ್ರಿ. ಸೊ ದಟ್ ಇಸ್ ವೈ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಹಿಯರ್ ದ alumina is dissolved in a fused cryolite containing the little fluorspar. So whatever the cryolite makes aluminum, otherwise makes this alumina ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. Al plus 3 ಇರೋದ್ರಿಂದ makes this alumina is a good conductor of electricity. Okay, so while the fluorospar lowers the melting point of this complete electrolyte. ಏನು ಎಲ್ಲ ಇದನ್ನೆಲ್ಲ ಮಿಕ್ಸರ್ ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, ಈ ಕಂಪ್ಲೀಟ್ ಮಿಕ್ಸರ್ದು ಏನದು ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಿರ್ತದಲ್ಲ ಅದನ್ನ ಕಡಿಮೆ ಮಾಡ್ತದ. ಎಷ್ಟಿಗೆ ಕಡಿಮೆ ಮಾಡ್ತದಪ್ಪ ಅಂತಂದ್ರೆ ಅರೌಂಡ್ ಇಟ್ ವಿಲ್ ಬಿ 1173 ಕೆಲ್ವಿನ್ಗೆ ಕಡಿಮೆ ಮಾಡ್ತದ. ಒಂದು ಕಂಟೈನರ್ ತಗೋತೀವಿ ನಾವು. ಓಕೆ, ಹೌ ದ ಕಂಟೈನರ್ ವಿಲ್ ಬಿ ದೇರ್ ಮೀನ್ಸ್ ಇನ್ ದ ಸೆನ್ಸ್ ಐ ವಿಲ್ ಶೋ ಯು ರೈಟ್ ನೌ. In that container, what you are taking, one is a, yes, you may notice here, ಇಲ್ಲಿ ನಿಮಗೆ ಈ ಪಿಕ್ಚರ್ ದಾಗ ಕಾಣ್ತದ ನೋಡ್ರಿ, ಬರ್ದಾರ ನೋಡ್ರಿ ಅಲ್ಲಿ molten alumina. Okay, it will be shown molten, where the molten alumina is there right now. Okay, here it is a molten aluminium and alumina or aluminium. So here it is a cryolite Na3Al6. To this, apart from that one, we are adding the somehow little bit we are adding to this fluorospar. Fluorospar just lowers the melting point of all this mixture. By adding of this, what is the reason for the adding of the cryolite means in the sense alumina makes it will makes alumina as a good conductor of electricity. Good conductor of electricity. Just alumina is not a good conductor of electricity. Molten alumina is not a good conductor of electricity. So by make it as a good conductor of electricity, we need to add this whatever the cryolite, having the formula Na3Al6, what I am showing here. Okay, so this is how the thing. And what the arrangement will be made in this electrolytical cell means in the sense, it is a first of all iron tank, which will be shown here. It is an iron tank lined inside with the carbon, lining. Okay, this carbon lining itself is a act as a cathode. This carbon lining itself is act as a cathode. Okay, so next one is the carbon lining act as a cathode, and bunch of this copper clamp, other copper clamp containing the whatever the graphite rods. These are the graphite rods. Okay, these are the graphite rods are suspended in this electrolyte, act as a anode. Graphite rods or carbon anode anta bardiddare ಅವರು ಇಲ್ಲಿ, ನಡೀತದೆ, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಓಕೆ, so graphite rod act as a, that's what we call it as a anode, or graphite rod is suspended in this electrolyte, act as a anode. Okay, so this is how the thing. So what the actual operation will be working, some of you are writing, please don't write. Some of you are writing, we will notice your name at the end of the class. If you are writing means in the sense, we will give the time for you people for that. You may write it. Okay, so now electrolyte consists of the alumina dissolved in a fused cryolite, consists of the little fluorospar which will be taken in this tank. Okay, that electrolyte is converted with a layer of the powder coke, whatever this powder coke, minimize the loss of heat by the radiation. Temperature of this tank, around it will be 1173 Kelvin to 1223 Kelvin temperature. I repeat here, very important, the temperature of this overall tank will be get maintained here 1173 Kelvin to 1223 Kelvin. Okay, temperature of that one, and that is only the temperature which will be maintained, and complete that temperature which will be get controlled by your fluorospar Na3, what we call it as a fluorospar formula CaF2. Okay, so now on passing the electric current, we have the cathode here right now, we have the anode. So on passing the electric current, alumina is liberated at cathode. liberated at cathode, sink to the bottom, which will be shown in terms of right now here the outlet is there here, whatever the on passing alumina is liberated at in terms of the cathode. So oxygen is liberated at anode. Oxygen is liberated at anode. So oxygen is liberated at anode that react with the carbon, which will be produced the carbon monoxide and carbon dioxide. Whatever the liberated oxygen from the anode, that will combines with whatever the carbon linings are there here, this carbon lining. So this will going to form a carbon monoxide and another one is the carbon dioxide. Carbon monoxide and carbon dioxide. How the actual overall reaction which will be going to get carried out in this process means in the sense, right now, this is a what we have the Al2O3. Okay, what you are taking main alumina that will get combines with carbon, and we are going to give here the alumina and carbon dioxide, which will be whatever that carbon dioxide which will be going to get produced of, that will be. So if you make a balance of this one means in the sense, if you make a balance of this one means in the sense, so yes, 3C and 3 carbon. So this is how the overall reaction. Alumina which will be produced in terms of the cathode, alumina will be produced in terms of the cathode aluminium, and it will be at the bottom of the sink, it will be get covered off, and whatever the at anode the oxygen is there, that oxygen will be get combines with this carbon. Okay, this carbon, so that will be get combines with this carbon. So that carbon combines with oxygen to give you a carbon dioxide in this reaction. Carbon dioxide and as well as the carbon monoxide will be going to form. So in this manner, this is what we call it as a overall complete systematic arrangement of this structure. Okay, now what is the rule right now? Important rule. One by one, I'm going to once again glance of this one. What is the rule of this carbon lining right now? What is the rule of the carbon lining means in the sense, carbon lining act as a cathode. In this container, whatever the carbon lining, whatever that carbon lining act as a cathode. Yes or no? Carbon lining act as a cathode. Graphite rod act as a anode. Cathode kade aluminum liberate ಆಗ್ತದ. At a cathode side, aluminum is going to get liberated. At a anode, oxygen is going to get liberated. Oxygen is going to get liberated. So, an anode yaudantala act ಆಗ್ತದಪ್ಪ ಅಂತಂದ್ರೆ graphite rod, which will be suspended in that electrolyte. Okay, which will be suspended in that electrolyte. So now temperature of this overall container, which will be maintained in the maintained means in the sense 1173 Kelvin to 1223 Kelvin temperature, 23 Kelvin temperature, which will be maintained. Upon passing electric current, aluminum is, I repeat it once again, aluminum is liberated at cathode, oxygen is liberated at anode. Okay, whatever the react with graphite, whatever the yenidu graphite jote react ಆಗ್ತದಲ್ಲ oxygen, so upon 1 kg of electrolysis, or we may also call it as simply 1 kg of aluminum produces, means in the sense 1 kg of aluminum produce ಆಗ್ಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ half kg, that is 0.5 kg of graphite is burnt out. 1 kg ಅಲ್ಯೂಮಿನಿಯಂ ನಮಗೆ ಬರಬೇಕಾಗ್ಯದಪ್ಪ ಅಂತಂದ್ರೆ ಈ ರಿಯಾಕ್ಷನ್, ಈ ಕಂಪ್ಲೀಟ್ ಪ್ರಾಸೆಸ್ ದಿಂದ ಎಷ್ಟು ನಮಗೆ, how many means in the sense half kg of the graphite, whatever that your graphite is totally burnt off ಅಂತಂದ್ರೆ ಅಷ್ಟು ಗ್ರಾಫೈಟ್. ಅದಕ್ಕೆ ಅವಾಗ ಈ ಕಂಟೈನರ್ ದೊಳಗೆ ಗ್ರಾಫೈಟ್ ಲೈನಿಂಗ್ ಮಾಡ್ಕೋತಿರ್ತಾರ. Means in the sense carbon lining will be a making complete in this process. Okay, so this is how the thing we can get carried out. And important means in the sense role of this cryolite means in the sense makes molten aluminum as a good conductor. Just a molten aluminum is not a good conductor. By adding the cryolite only, molten whatever this aluminum is a good conductor of the electricity. Okay, already reactions na nodiri ನೀವು ಅಗಳೇನೆ ಬರ್ದಿದ್ ನಾನು. ಹೌದು, ಇಟ್ ವಿಲ್ ಬಿ Na3AlF6 split up ಆಗಿ ಏನಾಗ್ತದ್ರಿ, sodium fluoride ಆಗ್ತದ. ನೆಕ್ಸ್ಟ್ aluminum fluoride. So later on that aluminum fluoride will be split up into aluminum. That makes alumina as a good conductor. And CaF2, what is the rule of this CaF2 fluorspar ಅಂತಂದ್ರೆ that is makes melting point lowers the melting point of your complete electrolyte. So how the ionization, important reaction. Okay, important reaction. ಈಗ ಹೆಂಗೆ ಅಯೋನೈಸೇಷನ್ ಆಗ್ತದ ಈ ಅಲ್ಯೂಮಿನಿಯಂ ಅಂತಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂದಾಗ Al2O3 ಇರ್ತದಲ್ಲ, ಅದು ನಿಮ್ಗೆ ಕಾಮನ್ ಆಗಿ ಬಾಕ್ಸ್ ಆಯ್ತು ಹೇಳೋದಂತಂದ್ರೆ, ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್. ಇಟ್ ವಿಲ್ ಗಿವ್ ಯು Al+3 plus oxygen. That is a 3, and right now if you are taken here the 2, now it is a balanced one. You may notice here Al2O3 gives you 2Al+3 ions plus 3O-2 oxygen. Okay, this is what we have the overall reaction. What the reaction which will be get carried out in terms of the anode, and what about the reaction which will be carried out in terms of the cathode is a very important right now. Henge iga first reaction in terms of the anode. Anode side ಏನಾಗ್ತದ, anode side ಏನ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತದ ನಿಮಗೆ ಗೊತ್ತದ ಆಲ್ರೆಡಿ. ಏನ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತದ್ರಿ, what about the anode side ಏನ್ ಪ್ರೊಡಕ್ಷನ್ ಏನಾಗ್ತದ?
Oxygen, sir.
Yes, very good. Oxygen is going to produced. Yes, very good. So ಆ ಆಕ್ಸಿಜನ್ ಎದ್ರ ಜೊತೆ ಕಾಂಬಿನೇಷನ್ ಆಗ್ತದ? ಯುವರ್ ಕಾರ್ಬನ್. Okay, that is in the form of a O-2. Okay, it will give you CO, gas here it is, plus 2 electrons at anode. Try to understand what I'm writing this reaction here. It is from the anode. Same, that is a carbon. ಏನೇನ್ ಪ್ರೊಡಕ್ಷನ್ ಆಗ್ತದಂತ ಹೇಳಿದ್ದೆ ನಾನು? When the oxygen is evolved from this anode, get combines with carbon to give you carbon monoxide and as well as carbon dioxide. Okay, plus 2O-2 gives you. Okay, so it will be in terms of the carbon dioxide plus 4 electrons. So this is how. Okay, yes, very good Apurva. So carbon get combines with this oxygen, gives you a carbon dioxide. It is completely from the anode side. Okay, anode side ನಮಗೆ ಏನ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ಲಿಕತ್ತಿರ್ತದ ಆಕ್ಚುಲ್ ಆಗಿ ಅಂತಂದ್ರೆ ಆಕ್ಸಿಜನ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿರ್ತದ. ಆ ಆಕ್ಸಿಜನ್ ಕಾರ್ಬನ್ ಜೊತೆ ಕಾಂಬಿನೇಷನ್ ಆಗ್ತದ. ಕಾರ್ಬನ್ ಜೊತೆ ಕಾಂಬಿನೇಷನ್ ಆಯ್ತಪ್ಪ ಅಂತಂದ್ರೆ this is what we call it as a anodic reaction. We are going to produce you carbon monoxide and as well as a carbon dioxide. Okay, yes, very good. So next one, reaction in terms of the cathode side. Cathode kade ಏನ್ ರಿಯಾಕ್ಷನ್ ಆಗ್ತದೆ? Cathode kade ಏನ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ನೇನಪ್ಪ ನಾನು?
Aluminium.
Yes, very good. Aluminium, that too aluminium, it is in terms of the molten form, isn't it? It is in terms of the molten form. Just you are writing here the in terms of the melt plus it will be get combines with 3 electrons. Okay, and you are going to give here the alumina, crude alumina, that too. That is in terms of the liquid form, or we may write here. Okay, so this is how the thing alumina. It is from the cathode. What are written here? The ionization reaction barde, reaction in terms of the anode barde, reaction in terms of the cathode barde. How the splitting of the your ಕ್ರಯೋಲೈಟ್ ಹೆಂಗ್ ಸ್ಪ್ಲಿಟ್ಟಿಂಗ್ ಆಗ್ತದ ಅನ್ನೋದನ್ನು ಬರ್ದಿದ್ದೆ ನಾನು, ಹೌದಾ ಇಲ್ಲ? ಸೊ ಆಲ್ ದೀಸ್ ರಿಯಾಕ್ಷನ್ಸ್ ಆರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. Carries 3 marks by writing the diagram. What has shown your diagram? Okay, same diagram, respective parts we have to represent. ಏನೇನ್ ಪಾರ್ಟ್ಸ್ ಅದು, ಕಾರ್ಬನ್ ಲೈನಿಂಗ್ ಯಾವುದು, ಆನೋಡ್ ಯಾವುದು, ಕ್ಯಾಥೋಡ್ ಯಾವುದು, ಅಲ್ಲಿ ಪ್ಯಾಸೇಜ್ ಮೊಲ್ಟನ್ ಅಲ್ಯೂಮಿನಿಯಂ ಹೋಗ್ಲಿಕ್ಕೆ, everything. And that diagram is also there in your text also, you may refer. Okay, so this is how the complete process of the extraction of the aluminium. ಬಾಕ್ಸೈಟ್ ಅಂತ ಕೇಳಿದಾಗ ನಾವು ಕೇರ್ಫುಲ್ ಆಗಿ ಬರಿಬೇಕು. ಕಾಮನ್ ಆಗಿ ಏನಂತ ಹೇಳ್ಬಿಡ್ತೀವಿ, Al2O3 ಅಂತ ಹೇಳ್ತೀವಿ. ಅಲ್ಲಿ Al2OX OH ಟ್ವೈಸ್ 3 ಮೈನಸ್ 2X ಅಂತ ಹೇಳ್ತಿರ್ಬೇಕು. ಅರ್ಥ ಆಗ್ಲಿಗತ್ತದ ಹೇಳಿಗತ್ತಿರೋದು ನಾನು ನಿಮಗೆ. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ ಥಿಂಗ್ ವಿ ಕ್ಯಾನ್ ಡೂಯಿಂಗ್. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ yes, like this, the extraction of aluminium carried out by Hall-Héroult process, and which is mainly depends upon the electrolysis of alumina. ಅರ್ಥ ಆಯ್ತ್ರಿ ಹೇಳಿಗತ್ತಿರೋದು ನಾನು ನಿಮಗೆ. ಅಯೂಬ್, ಪ್ಲೀಸ್ ಮ್ಯೂಟ್ ಯುವರ್ ಮೈಕ್. yes, mute your mic, Ayub. yes. So this is how the thing. ಅರ್ಥ ಆಯ್ತಾ? ಈ ಚಾಪ್ಟರ್ ದ ಲಾಸ್ಟ್ ಬಿಟ್ಟಿಗೆ ಬರ್ತೀವಿ ನಾನು ನೆಕ್ಸ್ಟ್. ಬಿಫೋರ್ ಎಕ್ಸ್ಪ್ಲೈನಿಂಗ್ ದ ಲಾಸ್ಟ್ ಬಿಟ್, ಸ್ಟಿಲ್ ಒನ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಬಿಟ್ ಇಸ್ ದೇರ್. ಯಾವ ಬಿಟ್ಟಪ್ಪ ಅಂತಂದ್ರೆ ಅದು, ದಟ್ ಈಸ್ ಇಷ್ಟೋತನ ನಾವು ಮೆಟಲ್ ಅನ್ನ ಏನ್ ಮಾಡಿ ತೆಗಿತಿದ್ವಿ, ನಾವು ಈ ಕ್ರೂಡ್ ಮೆಟಲ್ ಅನ್ನ ಆಕ್ಸಿಡೇಷನ್ ಮಾಡಿ ತೆಗಿತಿದ್ವಿ, ಏನ್ ರಿಡಕ್ಷನ್ ಮಾಡಿ ತೆಗಿತಿದ್ವೋ? ಎಲ್ಲಾ ಕಡೆ ನಾವು ಯಾವ್ದು ಪ್ರಿನ್ಸಿಪಲ್ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ? ಆಕ್ಸಿಡೇಷನ್ ರಿಡಕ್ಷನ್? ಕಿರಣ್, ರಿಡಕ್ಷನ್ ವಿಚ್ ವಿಲ್ ಬಿ ಅಪ್ಲಿಕೇಬಲ್. ಎಲ್ಲಾ ಕಡೆ ನಾವ್ ಏನ್ ಮಾಡಿದ್ವಿಪ್ಪ ಅಂತಂದ್ರೆ ರಿಡಕ್ಷನ್ ಅಪ್ಲಿಕೇಬಲ್ ಮಾಡಿದ್ವಿ ನಾವು, ವಿಚ್ ವಿಲ್ ಬಿ ಬೇಸ್ಡ್ ಅಪಾನ್ ಕಂಪ್ಲೀಟ್ಲಿ ರಿಡಕ್ಷನ್. ಹೌದಾ ಇಲ್ಲ? ರಿಡಕ್ಷನ್ ಅನ್ನ ನಾವು ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ ಬೇಸ್ಡ್ ಅಪಾನ್ ದ ರಿಡಕ್ಷನ್. ದ ಸರ್ಟನ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಷನ್ಸ್ ಆರ್ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ದೋಸ್ ಆಫ್ ದ ನಾನ್ ಮೆಟಲ್ಸ್ are based upon the oxidation also, are based upon the oxidation, not only by reduction. ಈಗೆಲ್ಲ ಅಪ್ಲಿಕೇಬಲ್ ಮಾಡಿದ್ದೆಲ್ಲ ನಾವು ರಿಡಕ್ಷನ್ ಅದು, ಹೌದಲ್ಲ? ರಿಡಕ್ಷನ್ ಮಾಡಿ ನಾವು ಮೆಟಲ್ ಅನ್ನ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ದದ, ಹೌದಾ? ಸಿಮಿಲರ್ಲಿ ಆಕ್ಸಿಡೇಷನ್ ಕ್ಯಾನ್ ಆಲ್ಸೋ ಅಪ್ಲಿಕೇಬಲ್. ದಟ್ಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಆಕ್ಸಿಡೇಷನ್ ರಿಡಕ್ಷನ್. What you have the actual bit, oxidation and reduction. A very popular example in this isolation of the chlorine by carried out by the electrolysis of strong aqueous solution of a sodium chloride. Electrolysis of strong aqueous solution of brine solution ಅಂತನೂ ಕರಿತೀವಿ ನಾವು ಸಿಂಪಲ್ ಆಗಿ. ಹೆಂಗೆ how the reaction will be working here, ಅಲ್ಲಿ ಹೆಂಗೆ ರಿಯಾಕ್ಷನ್ ವರ್ಕಿಂಗ್ ಆಗ್ತದ ಈ ಆಕ್ಸಿಡೇಷನ್ ಅಂತಂದ್ರೆ, ನೋಟಿಸ್ ಹಿಯರ್. ಈಗ sodium chloride brine solution ಅಂತಂದ್ರೆ aqueous solution of the sodium chloride only. okay, so NaCl will give you Na plus Cl minus, Na plus Cl minus. ಹೌದಾ? aqueous solution form, ಆದ್ರೂ aqueous ಅಂದ್ರೆ brine solution ದಾಗೆ. okay, similarly here the for that we need the water. okay, so how we are writing here the H plus Cl minus. It is particularly carried out in terms of the cathode, and it is, this will be a get no H plus ಆದ್ಮೇಲೆ ಈ ಕಡೆ ಏನ್ ಬರ್ಬೇಕ್ರಿ? OH minus. It is carried out, it is particularly carried out, it is in terms of the anode. At cathode, H plus ions lesser discharge potential than your sodium ions. Similarly, while at anode, whatever the chlorine ions, Cl minus ions are discharged in preference of OH minus ions. Both Na plus and OH minus remains in a solution as a NaOH. ಆಕ್ಚುಲ್ ಆಗಿ ಹೆಂಗೆ ಇದು ಆಕ್ಸಿಡೇಷನ್ ಆಗ್ತದಪ್ಪ ಅಂದ್ರೆ ನಿಮಗೆ ಓವರ್ ಆಲ್ ರಿಯಾಕ್ಷನ್ ಬರ್ ತೋರಿಸ್ತೀನಿ ನೋಡ್ರಿ. ಈಗ NaCl ಹೌದಾ, ಅಕ್ವಿಯಸ್ ಸೊಲ್ಯೂಷನ್ ಇದ್ದಾಗ ವಾಟರ್ ಇರ್ತದ. ಇದು ಏನಾಗ್ತದ್ರಿ ರಿಯಾಕ್ಷನ್ ಏನಾಗ್ತದೆ, ಇದು ಇಟ್ ವಿಲ್ ಗಿವ್ ಯು NaOH ಪ್ಲಸ್ H2 ಪ್ಲಸ್ Cl2 ಹೌದಾ. ಸೊ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಆಫ್ ದಿಸ್ ರಿಯಾಕ್ಷನ್ you need to take care the 2 coefficient. Hope so it is balanced right now. Brine solution means in the sense aqueous solution of sodium chloride. Aqueous solution of sodium chloride, that's what we call it as a simply brine solution. Aqueous solution of the sodium chloride ಗೆ ನಾವೇನಂತ ಕರಿತೀವಪ್ಪ ಅಂತಂದ್ರೆ brine solution ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ಈ ರಿಯಾಕ್ಷನ್ ಬರ್ದಿನಲ್ಲ ನಾನೀಗ. ಈ ರಿಯಾಕ್ಷನ್ ದಲ್ಲಿ both Na plus and OH minus ions remains in a solution as a NaOH, while H2 and NaOH solution are the byproduct in the reaction which is carried out in terms of the isolation of the chlorine. Last ಗೆ ನಮಗೆ ಏನ್ ಬರ್ಲಿಗತ್ತದ, ಇಲ್ಲಿ ಕ್ಲೋರಿನ್ ಬರ್ಲಿಗತ್ತದ ಹೌದಾ ಅಲ್ಲ. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಆರ್. ಕ್ಲೋರಿನ್ ಏನಾಗ್ಲಿಗತ್ತದ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ರಿಯಾಕ್ಷನ್ ದಾಗಪ್ಪ ಅಂತಂದ್ರೆ ದಟ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಅಸ್ ಆಕ್ಸಿಡೇಷನ್ ಆಗ್ಲಿಗತ್ತದ. ನೋಡಿರ್ಬೇಕಾದ್ರೆ ನೀವು ಇಲ್ಲೇನದ Na ಪ್ಲಸ್ ಅದ, ಇಲ್ಲಿ ಕ್ಲೋರಿನ್ ಏನದ -1 ಅದ, ಅಂಡ್ ಅಟ್ ದ ಎಂಡ್ ವಾಟ್ ಯು ಆರ್ ದ ಪ್ರಾಡಕ್ಟ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗಿವ್ ಯರ್ ಇಟ್ ದ ಕ್ಲೋರಿನ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಗಿವ್ ಯರ್ ದ 0 ಅಂದ್ರೆ -1 ಇಂದ 0 ಆಯ್ತು ಅಂದ್ರೆ ಕ್ಲೋರಿನ್ ಏನಾಯ್ತು, ಆಕ್ಸಿಡೈಸ್ ಆಯ್ತು ಹೌದಾ ಇಲ್ಲ, ಆಕ್ಸಿಡೈಸ್ ಆಯ್ತು. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ thing we can come across oxidation. Brine solution, by the brine solution chlorine can be get extracted by a oxidation, not a reduction, by a oxidation howda illa. So this is how the thing. And we are also come across in ಲೀಚಿಂಗ್ ದೊಳಗೆ ಗೋಲ್ಡು ಮತ್ತೆ ಸಿಲ್ವರ್ ನ ಸೋಡಿಯಂ ಸೈನೈಡ್ ಪೊಟ್ಯಾಷಿಯಂ ಸೈನೈಡ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡ್ತೀವಿ ನಾವು ಹೌದಾ ಇಲ್ಲ. ಸೊ ಅಲ್ಲಿನೂ ನಮಗೆ ಏನಾಗ್ತದಪ್ಪ ಅಂತಂದ್ರೆ ಆಕ್ಸಿಡೇಷನ್ ಆಫ್ ದ ಮೆಟಲ್. ಆ ಮೆಟಲ್ ಅನ್ನ ಕಾಂಪ್ಲೆಕ್ಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ. ಆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅನ್ನ ಮತ್ತೆ ಇನ್ನೊಂದು ಅದಕ್ಕಿಂತ ಯಾವುದರೆ ಸ್ಟ್ರಾಂಗ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಅಂದ್ರೆ ಮೋರ್ ಇಲೆಕ್ಟ್ರೋ ಪಾಸಿಟಿವ್ ಇರ್ತಕ್ಕಂತ ಮೆಟಲ್ ಅನ್ನ ತಗೊಂಡ್ಬಂದು ಅದ್ರ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದಾಗ ನಮಗೆ ಏನ್ ಬರ್ತದಪ್ಪ ಅಂತಂದ್ರೆ ಪ್ಯೂರ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಬರ್ತದೆ. ಅಲ್ಯೂಮಿನಿಯಂ ಮತ್ತು ಸಾರಿ your silver or gold precipitation what you are going to give. So in this manner the thing which will be going to get carried out. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳಕತ್ತಿರೋದು? ಓಕೆ, so this is how the oxidation, not only by reduction, you have learned the reduction method, so many reduction methods, not only reduction but also oxidation method also there for the what we call it as simply extraction of the these metals. Okay, so now we will move towards the refining techniques. Next bit of your topic, that's what we call it as a refining technique. Refining technique ಅಂತಂದ್ರೆ ಏನು ಹಾಗಾದ್ರೆ? ಈಗ ಇಲ್ಲಿ ರಿಫೈನಿಂಗ್ ಟೆಕ್ನಿಕ್ ಅಪ್ಪ ಅಂತಂದ್ರೆ ಪ್ಯೂರಿಫಿಕೇಶನ್ ಮೆಥಡ್ಸ್ ಅಂತ ಹೇಳ್ದಂಗೆ ಸಿಂಪಲ್ ಆಗಿ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಆಫ್ ಯುವರ್ ಮೆಟಲರ್ಜಿಕಲ್ ಪ್ರೊಸೆಸ್. ನೀವು ಆಲ್ರೆಡಿ ಎಲ್ಲಾ ಪ್ರೊಸೆಸ್ ಎಲ್ಲಾ ಮೆಥಡ್ಸ್ ಅನ್ನ ಕಲ್ತಿರ್ ನೀವು ಆಲ್ರೆಡಿ ಈಗ ಹೌದಾ ಇಲ್ಲ, ಬೇರೆ ಬೇರೆ ಪ್ರೊಸೆಸ್ ಅನ್ನ ಕಲ್ತಿದ್ದದ. ಸೊ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಏನ್ ಮಾಡ್ತೀವಪ್ಪ ಅಂತಂದ್ರೆ ಕ್ರೂಡ್ ಮೆಟಲ್ ಬಂದಿರ್ತದ, ನಮಗೆ ಕ್ರೂಡ್ ಮೆಟಲ್ ಬಂದಿರ್ತದ. ಆ ಕ್ರೂಡ್ ಮೆಟಲ್ ಅನ್ನ ನಾವು ಏನ್ ಮಾಡ್ತೀವಿ, we are going to get purified metal ಬೇಕಲ್ಲ ನಮಗೆ. you come across the 3% of the carbon, 2% of the carbon, in between 2% and 4% of the carbon we have the another carbon percentage there, means in the sense that iron we call it as a different names like pig iron, earth iron, steel, like different meanings are there. Okay, so we need to purify that one. Purified bekappa antandre we need to follow the different refining techniques, different purification techniques. Okay, so that refining will be get carried out in terms of the different manner for the different metals, for the different refining techniques are there. So we will be explaining right now one by one right now. Okay, so what you first method, that's what we call it as a distillation anta ಹೇಳ್ತೀವಿ ನಾವು. ಇಲ್ಲಿ ಡಿಸ್ಟಿಲೇಷನ್ ಫಸ್ಟ್ ಮೆಥಡ್ ರಿಫೈನಿಂಗ್ ಟೆಕ್ನಿಕ್ ದೊಳಗೆ ಏನ್ ಇಲ್ಲಿ ಡಿಸ್ಟಿಲೇಷನ್ ಅಪ್ಪ ಅಂತಂದ್ರೆ it will be used for the low boiling metals like ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ ವಾಲಟೈಲ್ ಮೆಟಲ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಲೋ ಬಾಯ್ಲಿಂಗ್ ಮೆಟಲ್ಸ್ ಯಾವುವು? ಜಿಂಕು, ಮರ್ಕ್ಯುರಿ, ಹೌದಾ? ಸೊ ದೀಸ್ ಆರ್ ದ ಲೋ ಬಾಯ್ಲಿಂಗ್ ಮೆಟಲ್ಸ್ ವಿಚ್ ವಿಲ್ ಬಿ ಹೀಟೆಡ್ ಇನ್ ಅ ಸರ್ಟನ್ furnace. It will be operate separately and get condensed and recovers. It will be get recovered, and whatever the non volatile impurities are there, that will be left behind in that container only. ಆ ಮೆಟಲ್ ಅನ್ನ ಏನ್ ಮಾಡ್ಬಿಡ್ತೀವಪ್ಪ ಅಂತಂದ್ರೆ ಹೀಟ್ ಮಾಡಿದಾದ್ಮೇಲೆ ಆ ಮೆಟಲ್ ಅನ್ನ ಹೀಟ್ ಮಾಡ್ಕೋತ ಹೋಗ್ಬಿಡುದು, ಹೌದಾ? ಕ್ರೂಡ್ ಮೆಟಲ್ ಇರ್ತದ, ಆ ಕ್ರೂಡ್ ಮೆಟಲ್ ಹೀಟ್ ಮಾಡ್ಕೋತ ಹೋದಾಗ ಏನಾಗ್ತದ, ಆ ಮೆಟಲ್ ಏನಾಗ್ತದ, ಕಂಪ್ಲೀಟ್ ಆಗಿ ಎವಾಪರೇಟ್ ಆಗ್ತದ. ಎವಾಪರೇಟ್ ನೀವು ಕನ್ನಡದಾಗ ಹೇಳ್ತೀರಿ ನೋಡ್ರಿ, ಬಟ್ಟೆ ಇಳಿಸುವಿಕೆ, ನೀರಿನ ಬಟ್ಟೆ ಇಳಿಸುವಿಕೆ. ನೀರಿನ ಬಟ್ಟೆ ಇಳಿಸುವಿಕೆ ಮಾಡಿದಾದ್ಮೇಲೆ ಏನ್ ಬರ್ತದ ನಮಗ? ಕಿರಣ್,
ಶುದ್ಧ ನೀರ್ ಬರ್ತೈತಿ.
ಶುದ್ಧ ನೀರ್ ಬರ್ತದಲ್ಲ, ಹಂಗ ಶುದ್ಧ ನೀರ್ಗತೆನೆ ಇಲ್ಲಿನೂ ಏನ್ ಬರ್ತದಪ್ಪ ಅಂತಂದ್ರೆ ನಮಗೆ ಶುದ್ಧ ಮೆಟಲ್ ಬರ್ತದ, ಇಲ್ಲಿ ಶುದ್ಧ ಲೋಹ ಬರ್ತದ ನಮಗೆ ಇಲ್ಲಿ, ತಿಳಿತಲ್ಲ? ಸೊ ದಟ್ಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಡಿಸ್ಟಿಲೇಷನ್ ಆಫ್ ದ ಮೆಟಲ್ ಅಂದಂಗೆ. ವೈ ಇಟ್ ಈಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಅಪ್ಲಿಕೇಬಲ್ ಫಾರ್ ದ ಲೋ ಬಾಯ್ಲಿಂಗ್ ಮೆಟಲ್ಸ್. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳಿಗತ್ತಿರೋದು? ಲೋ ಬಾಯ್ಲಿಂಗ್ ಮೆಟಲ್ಸ್. ಸೊ ದಿಸ್ ಇಸ್ ಒನ್ ಮೆಥಡ್. ಇಟ್ ವಿಲ್ ಬಿ ಅಪ್ಲಿಕೇಬಲ್ ಫಾರ್ ದ ಮೆಟಲ್ಸ್ ಲೈಕ್ ದ ಜಿಂಕ್ ಅಂಡ್ mercury. Next one is a liquefaction ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಇದು liquefaction. The method is purification which will be applicable for if a metal have a same low melting point. ಆಗಳೆದು low boiling point ಅದು. Try to understand my concept. Distillation is purely applicable for metal which we have a low boiling point. For the liquefaction, low melting point. Okay, so while impurity will be present in the have a high melting point, impurity the melting point high irtada, metal the melting point low irtada. Metal the melting point low irtada, impurity the melting point high irtada. Hanta metal yavyavappa antandre ಟಿನ್ನು ಮತ್ತೆ lead. ಈ ಮೆಟಲ್ಸ್ ಇದ್ದು ಈ ಮೆಟಲ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಷನ್ ಮಾಡ್ಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ ನಾವು ಲಿಕ್ವಿಯೇಷನ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಹೆಂಗೆ? ಇದು ಒಂದು ನೀವು ಡಯಾಗ್ರಾಮ್ ನೋಡಿದ ಕೂಡ ನಿಮ್ಗೆ ಐಡಿಯಾ ಆಗ್ಬಿಡುತ್ತದೆ ಹೌ ದ ಲಿಕ್ವಿಯೇಷನ್ ವಿಲ್ ಬಿ ಡನ್ ಮೀನ್ಸ್ ಇನ್ ದ ಸೆನ್ಸ್. ಐ ಆಮ್ ಶೇರಿಂಗ್ ಯು ರೈಟ್ ನೌ ಇನ್ ದಿಸ್ ಪಿಕ್ಚರ್. ಯು ಮೇ ನೋಟಿಸ್ ಹಿಯರ್ ಇಂಪ್ಯೂರ್ ಮೆಟಲ್ ಇಲ್ಲಿ ಹಾಕ್ಲಿಗತ್ತಾರ ನೋಡ್ರಿ ಇಲ್ಲಿ, ಹೌದಾ? ಇಂಪ್ಯೂರ್ ಮೆಟಲ್ ಇಸ್ ದೇರ್ ಹಿಯರ್. ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಕಪ್ ಆಫ್ ಸ್ಲೂಪ್ ಅಂತ ಬರ್ತದೆ. ಹೀಟರ್ ಇದನ್ನು ಒನ್ ಆಫ್ ದ ಹೀಟರ್, ಹೌದಾ? ಈ ಹೀಟರ್ ಒಳಗೆ impurity will be left on this sloop only, sloop halt. This is what we call it as impurity will be left only here, and whatever the pure metal will come and collected in this complete furnace. This is what we call it as a liquefaction. Andre ಏನಾಗ್ತದೆ ಈಗ ಇಲ್ಲಿ? That is a impure metal is placed on the sloop heater of the furnace and gently heated to temperature slightly greater than that melting point of your metal. The metal melts and flow down the slope of the heart and collected in that whatever this container. This is what we call it as a pure metal. This is what we call it as a process. We call it as a liquefaction anta ಹೇಳ್ತೀವಿ ನಾವು. Next one is, that's what we call it as a electrical or electrolytical refining. Electrolytical refining. ಈಗ ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ? electrolytical refining ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀವಿ? This method is used to refine a large number of metals like copper, silver, lead, nickel, alumina, zinc, etc. Okay, this method is used to refine a large number of metals. It's what we call it as a electrolytic refining. One more important points ಹೇಳ್ತೀನಿ, listen we are very carefully. First ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ thin sheet of a impure metal is made as a anode. Thin impure metal sheet will be taken as a anode. Thin sheet of a pure metal of a same metal, ಅದೇ ಯಾವ್ದು ತಗೊಂಡಿರ್ತಿ, ಈಗ ಕಾಪರ್ ತಗೊಂಡ್ರೆ ಕಾಪರೇ, ಅರ್ಥ ಆಗ್ಲಿಕ್ಕೆ ಹೇಳಿಗತ್ತಿದ್ದು. ಓಕೆ, thin sheet of a pure metal is made as a cathode. Okay. Electrolyte compresses aqueous solution of a suitable salt of a same metal acidified with corresponding acid. ನೀ ಯಾವ ಮೆಟಲ್ ತಗೊಂಡಿರ್ತೀಯಲ್ಲ ಅದರದೇ ಮೆಟಲ್ ಸಾಲ್ಟ್ ನ acidified solution aqueous solution ತಗೋಬೇಕು. ಆಯ್ತಾ? ಪಾಯಿಂಟ್ ಕ್ಲಿಯರ್ ಆಯ್ತಾ? On passing the current, pure metal is deposited on a cathode. Pure metal and now pure metal you have taken in terms of the cathode. Of course, on passing the electric current, pure metal is deposited at a cathode and having a same equivalent amount of a metal which will be dissolved in form of the anode. So the metal transferred from anode to cathode. ಆನೋಡ್ ಟು ಕ್ಯಾಥೋಡ್ ಅಂದ್ರೆ ಆನೋಡ್ ದಿಂದ ಕ್ಯಾಥೋಡ್ ಆಗಿ ಅಂದ್ರೆ ಆನೋಡ್ ಆಗಿ ಏನೇನ್ ಪ್ಯೂರ್ ಮೆಟಲ್ ಇರುತ್ತಲ್ಲ ದಟ್ ವಿಲ್ ಬಿ ಮೂವ್ ಟುವರ್ಡ್ಸ್ ದ ಕ್ಯಾಥೋಡ್. ಅರ್ಥ ಆಗ್ಲಿಕ್ಕತ್ತದಲ್ಲ? ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ ಥಿಂಗ್. ದ ಮೋರ್ electropositive metals present in a crude metal as a impurity go into a solution of the ions. Okay, less electropositive are collected below at anode and that we call it as a anode mud, otherwise anode sludge ಅಂತನು ಹೇಳ್ತೀವಿ ನಾವು. ಮೋರ್ electropositive ಏನೇನ್ ಇರುತ್ತದಲ್ಲ that will be moved towards always in terms of the cathode side and present, that's what we call it as a pure ಅಂದ್ರೆ ions will be moving towards the cathode side. ಪ್ಯೂರ್ ಇದ್ದಿದ್ದು ಯಾವ ಇಂಪ್ಯೂರ್ ಇರ್ತದಲ್ಲ, ಯಾವುದು ಲೆಸ್ electropositive ಅಂತಂದ್ರೆ ಲೆಸ್ electropositive ಏನಂತ ಹೇಳ್ತೀವಲ್ಲ, ಆ ಲೆಸ್ electropositive ಇರ್ತಕ್ಕಂಥದ್ದು that will be collected in terms of the anode and that we call it as a anode mud ಅಂತ ಕರಿತೀವಿ, anode sludge ಅಂತ ಕರಿತೀವಿ. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಈಗ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಅಪ್ಪ ಅಂತಂದ್ರೆ ಈಗ ಇಲ್ಲಿ ನಾನು ಕಾಪರ್ ತೋರಿಸ್ತೀನಿ ನೋಡ್ರಿ. ಹೌ ದ ಕಾಪರ್ ವಿಲ್ ಬಿ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಕ್ಯಾರಿಡ್ ಔಟ್ ಅಟ್ ಆನೋಡ್ ಸೈಡ್. ರಿಯಾಕ್ಷನ್ ವಿಲ್ ಬಿ ಗೆಟ್ ಕ್ಯಾರಿಡ್ ಔಟ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ದ ಆನೋಡ್ ಸೈಡ್. ಹೌದಾ? ಆನೋಡ್ ಸೈಡ್ ಏನಾಗ್ತದ, ಕಾಪರ್ ವಿಚ್ ವಿಲ್ ಬಿ ಸಾಲಿಡ್, okay, will give you a Cu plus 2 plus 2 electrons. Okay, at the cathode side, how the thing will be going on in terms of the cathode side, ಏನಾಗ್ತದ, whatever the Cu plus 2 form ದಾಗಿರ್ತದ, ಆ Cu plus 2 plus 2 electron will be combines to give you a pure copper. Here it is, whatever this is what we call it as a pure copper. It is going to give you in terms of the cathode side. ಇಲೆಕ್ಟ್ರೋಲೈಟ್ ಯಾವ ಯಾವಪ್ಪ ಅಂತಂದ್ರೆ ಈ ಕಂಪ್ಲೀಟ್ ಓವರ್ ಆಲ್ ರಿಯಾಕ್ಷನ್ ಅಪ್ಪ ಅಂತಂದ್ರೆ CuSO4 ಕಾಪರ್ ಸಲ್ಫೇಟ್ ಸೊಲ್ಯೂಷನ್ ವಿಚ್ ವಿಲ್ ಬಿ acidified. You may take the HCl or you may take the H2SO4. most common ಅಪ್ಪ ಅಂತಂದ್ರೆ H2SO4 is a better common ion ಆಗ್ತದೆ. ಇಲ್ಲಿ SO4 that's what we call it as thick sheet of a impure copper metal. Thick sheet of a impure copper metal act as a what we call it as a anode, and pure copper sheet which will be act as a cathode. Cathode side ನಮಗೆ purified metal ಬರ್ತದ. ಅರ್ಥ ಆಯ್ತಾ? electropositive metals like ಅಂದ್ರೆ electropositive metallic impurities ಉಳಿದಿರ್ತದೆ. ಅಂದ್ರೆ less electropositive metallic impurities like silver, gold, platinum, selenium, tellurium, antimony, which will be settled down in terms of the anode side only. Anode side, that's what we call it as a anode mud or a anode sludge anta ಹೇಳ್ತೀವಿ ನಾವು. Okay, why? Because of they are less electropositive or less reactive, less electropositive, less reactive ಇರೋದ್ರಿಂದ so that will be present at in terms of the anode. ಯಾವುದು more electropositive ಇರ್ತದ, more reactive ಇರ್ತದಲ್ಲ, that will be moved towards the cathode. So like this is the main principle which will be behind this electrolytical refining. Okay, so next one is a zone refining. ಇದು ಯಾವುದು ಪ್ರಿನ್ಸಿಪಲ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ಯದಪ್ಪ ಅಂತಂದ್ರೆ ಬೇಸ್ಡ್ ಅಪಾನ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ದ impurity has greater soluble in a liquid state than in a solid state of a metal. Very important sentence, carries 1 mark. Zone refining technique. Next method is a zone refining technique or zone refining method. for a purification of specifically these semiconductors ದೊಳಗೆ ಇನ್ವಾಲ್ವ್ಮೆಂಟ್ ಆಗಿರ್ತಕ್ಕಂಥ ಮೆಟಲ್ಸ್ ಅವಲ್ಲ, ಯಾವ್ಯಾವು ಸಿಲಿಕಾನು, ಜರ್ಮಾನಿಯಂ, ಗ್ಯಾಲಿಯಂ, ಇಂಡಿಯಂ, ಥಾಲಿಯಂ ಅಂತ ಏನ್ ಹೇಳ್ತಿರಲ್ಲ, ಈ ಮೆಟಲ್ಸ್ ನ ಪ್ಯೂರಿಫಿಕೇಶನ್ ಮಾಡ್ಬೇಕಪ್ಪ ಅಂದ್ರೆ ನಾವು ಝೋನ್ ರಿಫೈನಿಂಗ್ ಟೆಕ್ನಿಕ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಇದು ಯಾವ ಪ್ರಿನ್ಸಿಪಲ್ ಮೇಲೆ ಅದಪ್ಪ ಅಂತಂದ್ರೆ, ಇಟ್ ಇಸ್ ಬೇಸ್ಡ್ ಅಪಾನ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ದಟ್ impurity has greater solubility in a liquid state than in a solid state of metal. Solid state of metal. Okay, illinu idu impurity has greater soluble in liquid state than in a liquid state of the metal ಅಂತಂದಾಗ, you may notice here ಇಲ್ಲಿನ ಒಂದು ನಿಮಗೆ ಒಂದು ಕ್ಲಿಯರ್ ಆಗಿ ಒಂದು ಡೈಗ್ರಾಮ್ ತೋರಿಸಿದ್ವಿಪ್ಪ ಅಂತಂದ್ರೆ, yes, before going to that you may notice here this is also ಈಗ ನಿಮಗೆ ಐಡಿಯಾ ಆಗ್ತದೆ. ಈಗ ಇದು pure metal, this is what we call it as a cathode, what you have come across in a last bit. Anode mud ಅಂತ ಹೇಳಿದ್ನಲ್ಲ ನಾನು ನಿಮಗೆ, this is what you have the anode mud right now. Electrolytical solution we have taken in this, and here it is what we electric current has been passed, means in the sense impure metal rod is what we call it as, and pure will be get it deposited like this. Okay, this is how for the electrolytic refining. Now zone refining ಏನ್ ಮಾಡ್ತೀವಿ ಈಗಲ್ಲಿ ಅಂತಂದ್ರೆ, ಈ ಇಂಡಕ್ಷನ್ ಕಾಯಿಲ್ ಹೀಟರ್ಸ್ ಅವ ನೋಡ್ರಿ ಇಲ್ಲಿ. going to see here, these are the induction coil heaters. These induction coil heaters can be moving. Okay, if you move the circular mobile heater, this is what we call it as a ಏನ್ ಆಗ್ತದೆ ಅಂತಂದ್ರೆ, impurity will be a come and settle at this corners. ಇಲ್ಲೇನು ಗ್ರೀನ್ ಕಲರ್ ತೋರಿಸಿದ್ದ, ಬ್ಲೂ ಕಲರ್ ತೋರಿಸಿದ್ದಲ್ಲ, like this is what we call it as. So impurity will be a come and settle here. Principle ಅದ ಅಂದ್ರೆ ಏನದ, impurity has a greater solubility in a liquid state than in a solid state of a metal ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ ನಾವು. Impurity has a ಗ್ರೇಟರ್ ಸಾಲಿಬಿಲಿಟಿ. ಇಲ್ಲಿ ಹೀಟ್ ಮಾಡಿದಾಗ, ಈ ಮೆಟಲ್ ಅನ್ನ ಹೀಟ್ ಮಾಡ್ಕೋತ ಹೋದಾಗ ಇದ್ರಾಗ ಇರ್ತಕ್ಕಂಥ ಇಂಪ್ಯೂರಿಟಿ ಏನಿರ್ತದಲ್ಲ, ದಟ್ ವಿಲ್ ಬಿ ಸಾಲಿಬಲ್ ಅಂಡ್ ಇಟ್ ವಿಲ್ ಬಿ ಕಮ್ ಅಟ್ ಕಾರ್ನರ್ಸ್ ಆಫ್ ದೀಸ್ ಮೆಟಲ್ ರಾಡ್. ಇದು ಈ ಮೆಟಲ್ ರಾಡ್ ದಾಗ ಈ ಕಾಯಿಲ್, ಇದು ಕಾಯಿಲ್, ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ as ಇಂಡಕ್ಷನ್ ಕಾಯಿಲ್ ಹೀಟರ್ ಮೂವಿಂಗ್. ಓಕೆ, ಸೊ ಇಫ್ ಇಟ್ ಇಸ್ ಮೂವಿಂಗ್ ಲೈಕ್ ದಿಸ್ ವೇ, ಮೀನ್ಸ್ ಇನ್ ದ ಸೆನ್ಸ್ ಲೈಕ್ ದಿಸ್, ಇಟ್ ವಿಲ್ ಬಿ ಅ ಮೂವ್ ಆದಂಗ ಒಂದ್ ಸೈಡ್ ಮೂವ್ ಆದಂಗ ಎಲ್ಲಾ ಇಂಪ್ಯೂರಿಟಿ ಬಂದು ಒಂದ್ ಕಡೆ ಸೆಟಲ್ ಆಗ್ತಿರ್ತದೆ. impurity will be a soluble, greater soluble. Impurity will be a greater soluble, means in the sense impurity will be a settled here. Settled means in the sense later on ಏನ್ ಮಾಡ್ತೀವಿ, ಇಲ್ಲಿ ಪ್ಯೂರಿಫೈಡ್ ಮೆಟಲ್ ಸಿಗ್ತದಲ್ಲ, ಈ ಇಂಪ್ಯೂರಿಟಿ ಇಂಪ್ಯೂರ್ ಮೆಟಲ್ ಏನಿರ್ತದಲ್ಲ, ದಟ್ ವಿಲ್ ಬಿ ಕಟ್ ಆಫ್. Okay, so this is how the thing we can come across in terms of the zone refining. Okay, zone refining method. So next one is vapor phase refining. Okay, zone refining admele vapor phase refining. Notes will be get posted in your WhatsApp group, don't bother about that one. So just you should know the thing. Okay, very important, carries 2 mark. These techniques are very important, carries 2 mark. Okay, now vapor phase refining. Impure metal can be converted into suitable volatile compounds. Vapor phase refining ಅಂತಂದ್ರೆ, impure metal is converted into suitable volatile compounds by heating with specific reagent, lowers the temperature and decompose the volatile compound by same at higher temperature to give you a ಪ್ಯೂರ್ ಮೆಟಲ್. ಇಲ್ಲಿ ಮೇನ್ ಆಗಿ ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ, ಇಂಪ್ಯೂರ್ ಮೆಟಲ್ ಏನಿರ್ತದಲ್ಲ, ಆ ಇಂಪ್ಯೂರ್ ಮೆಟಲ್ ಶುಡ್ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ವಾಲಟೈಲ್ ಕಂಪೌಂಡ್ ಬೈ ಆಡಿಂಗ್ somehow the reagents. By adding the somehow the reagent. ಇಂಪ್ಯೂರ್ ಮೆಟಲ್ ಅನ್ನು ಏನ್ ಮಾಡಿದ್ವಿ ನಾವು, ವಾಲಟೈಲ್ ಕಂಪೌಂಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ, ಸಮ್ ಬೈ ಆಡಿಂಗ್ ದ ಅಪ್ರೋಪ್ರಿಯೇಟ್ ರಿಯೇಜೆಂಟ್. ಆ ವಾಲಟೈಲ್ ಕಂಪೌಂಡ್ ಅನ್ನ ಈಸಿಯಾಗಿ ಡಿಕಂಪೋಸ್ ಮಾಡ್ತೀವಿ ಲೇಟರ್ ಆನ್. ಆ ವಾಲಟೈಲ್ ಕಂಪೌಂಡ್ ಅನ್ನ ಈಸಿಯಾಗಿ ಡಿಕಂಪೋಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಈಸಿಲಿ ರಿಕವರ್ ಪ್ಯೂರ್ ಮೆಟಲ್. ಆ ವಾಲಟೈಲ್ ಕಂಪೌಂಡ್ ಜೊತೆನೆ ಇಂಪ್ಯೂರಿಟಿನೂ ಹೋಗ್ಬಿಡ್ತದೆ. ಅರ್ಥ ಆತ ಹೇಳಿಗತ್ತಿರೋದು. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ ಥಿಂಗ್ which will be illustrated by the mainly 2 steps. Very important, so many times asked in your annual examination. Very important, so many times. First one is Mond's process. Okay, first one is it will be illustrated. This vapor phase refining technique will be illustrated by the 2 step. One is first one is, that's what we call it as a Mond's process, which will be purely applicable for the nickel, metal nickel. Mond's process applicable for Mond's process, which will be applicable for the nickel only. Metal, what we call it as a nickel. Okay, when an impure nickel metal is heated in current of the carbon monoxide, ಈ ನಿಕ್ಕೆಲ್ ಅನ್ನ ನಾವು in presence of the carbon monoxide, which will be heated around in terms of the 330 to 350 Kelvin, 350 Kelvin temperature, it will forms the volatile compound so called as a nickel tetracarbonyl complex. Nickel tetracarbonyl complex. Nickel tetracarbonyl complex. This is what we call it as a nickel tetracarbonyl complex. Red color underline ಮಾಡ್ಲಿಗತ್ತೀನಲ್ಲ, that's what we call it as a nickel tetracarbonyl complex. That's why what I am Ayub, same thing what I am explaining. Mond's process, what I am explaining right now. Mond's process, it's a one of the vapor phase refining method which is applicable for the nickel. Okay, which is applicable for the nickel. What a dark ದಾಗ ನಮ್ಮ ಫ್ರೆಂಡ್ ಇನ್ನೊಬ್ರು ಯಾರೋ ಡಾರ್ಕ್ ದಾಗ ಲೈನ್ ಮಾಡಿದ್ರು ನೋಡ್ರಿ ಈಗ. That is what we call it as a nickel tetracarbonyl compound. Okay, so this nickel tetracarbonyl obtained, ಇದನ್ನೇನ್ ಮಾಡ್ತೀವಪ್ಪ ಅಂತಂದ್ರೆ, ಈಗ ಬಂದಿದ್ದನ್ನ ಇದನ್ನ ನಿಕೆಲ್ ಟೆಟ್ರಾಕಾರ್ಬೋನಿಲ್ ಕಾಂಪೌಂಡ್ ನ ಮತ್ತೆ ನಾವು ಹೀಟ್ ಮಾಡ್ತೀವಿ. ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಗೆಟ್ ಡಿಕಂಪೋಸ್ ಆಗ್ಬೇಕದು ಅರೌಂಡ್ 450 ಕೆಲ್ವಿನ್ ಟು 470 ಕೆಲ್ವಿನ್ ತನ ನಾವು ಟೆಂಪರೇಚರ್ ನ ರೈಸ್ ಮಾಡಿದೀವಪ್ಪ ಅಂತಂದ್ರೆ ನಮಗೆ ಪ್ಯೂರ್ ನಿಕೆಲ್ ಬರ್ತದ ಪ್ಲಸ್ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್. ಎಸ್ ಭಾವನಾ, ಇಟ್ಸ್ ಕರೆಕ್ಟ್. ಓಕೆ, upon decompose to give you a nickel and carbon monoxide. So very important reaction, carries 1 mark or 2 mark. Mond's process. Mond's process purely applicable for the metal nickel. Keep it in your mind. Okay, next one is there. That's what we call it as a Van Arkel method. Next one is the Van Arkel method. This one is applicable for the purely metals like zirconium and titanium. For your kind information, this method is applicable for the metals zirconium and titanium. Okay, same principle which will be applicable here. The crude metal is heated in a evacuated vessel of iodine. Evacuated vessel of the iodine andre zirconium. Just I'm taking an example of the zirconium. Even same, it will be applicable for the titanium also. Evacuated iodine. Okay, it will gives you evacuated iodine. With iodine, the metal iodine is being a more covalent and volatilizes the metal iodine. Next, ಈ metal iodine ಈಗ zirconium. So if you balance this reaction, so need to take care the 2. Okay, so ಇದನ್ನ ಮತ್ತೆ ಡಿಕಂಪೋಸ್ ಮಾಡ್ತೀವಿ ಟಂಗ್ಸ್ಟನ್ ಫಿಲಾಮೆಂಟಲ್ ದೊಳಗೆ. ಈ ಬಂದಂತ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅನ್ನ there is no any particular temperature for this one. ಅರೌಂಡ್ ಏನಂತ ಹೇಳ್ತೀವಪ್ಪ ಅಂತಂದ್ರೆ ಅರೌಂಡ್ 1800 ಕೆಲ್ವಿನ್ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. Electricity about 1800 Kelvin temperature, it will be decomposed to give here the zirconium and iodine. So this is how the thing. These 2 reactions are very important one. Van Arkel method purely applicable for the zirconium and titanium. ಈ ಟಿಟಾನಿಯಂ ಬರಿಬೇಕಪ್ಪ ಅಂದ್ರೆ ಸೇಮ್ ಟಿಟಾನಿಯಂ. ಎಲ್ಲೆಲ್ಲಿ ZR ಅಂತ ಬರ್ದಿದ್ದದಲ್ಲ ಅಲ್ಲೆಲ್ಲ ಕಡೆ ಟಿಟಾನಿಯಂ TI ಅಂತ ಬರ್ಕೊಂಡ್ರೆ ಮುಗಿದೋಗ್ಬಿಡುತ್ತೆ. This is what we call it as a Van Arkel method for particularly refining of the zirconium and titanium. Okay, so this is how the thing we can come across. And at the last we come across the chromatography. You people are studied about the chromatography, yes or no? You heard the chromatography term, yes or no?
Yes, sir.
Yes, in a first PUC you people are studied this chromatography. Chromatography is a modern and most efficient method for the separation, purification and testing of a purity of element and as well as their compounds. Repeat here, very important. Chromatography is a modern, most efficient technique or a method for the separation, purification and as well as testing of a purity of a metals and their compounds. The whatever the chroma means in the sense that's what we call it as a color. Graphy means in the sense writing, like these Greek words are there. The color writing is no longer accurate. This means the now used to separate most of the given mixtures are that way, whatever the colorless color to the colorless. The technique of this chromatography is based upon the principle of the different compounds of the mixtures are different absorbed on a absorbent. Hope you will understand the meaning of absorbed and absorbent and absorbate. Studied already surface chemistry. Okay, I repeat here, the technique of the chromatography based upon the principle of different components of mixture are differently absorbed on absorbent. The mixture is put in a liquid gas medium which move through a porous medium. Okay, porous medium. So this is how the different component mixtures are in absorbate and absorbent are extracted from the absorbate, and that's what we call it as simply evolution. Depending upon the physical state of moving of that medium absorbed in a material and also the process of the passing of medium, and chromatography is different name which will be different name like column chromatography, thin layer chromatography and paper chromatography, gas chromatography. So what we have come across means in the sense ಅಲ್ಲಿ ಒಂದು ಕಂಪ್ಲೀಟ್ ಒಂದು ನೀವು ನಿಮ್ಗ ಇದನ್ ಮಾಡ್ಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ ಈಗ ಲೈಕ್ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಎಸ್ ಈಗ ಈ ತರ ಒಂದು ಕಾಲಮ್ಸ್ ಬರ್ತಾವ್. ದಿಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ದ ಮೇನ್ ಪ್ರಿನ್ಸಿಪಲ್ ಬಿಹೈಂಡ್ ದಿಸ್ ಒನ್ ಮೀನ್ಸ್ ಇನ್ ದ ಸೆನ್ಸ್ ಕಾಲಮ್ ಕ್ರೋಮೆಟೋಗ್ರಫಿ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಸೊ ಇಲ್ಲಿ ನಾವು ಏನ್ ಸೊಲ್ಯೂಷನ್ ಹಾಕ್ತಿವಿ, ಮೆಟಲ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಅನ್ನ ಹಾಕ್ತಿವಿ, ಅಲ್ಲಿ ಅಬ್ಸಾರ್ಬೇಟ್ ಇರ್ತಾವ, ಅವೆಲ್ಲ ಅಬ್ಸಾರ್ಡ್ ಆಗ್ತಾವ ಇದ್ರ ಮೇಲೆ ಕಂಪ್ಲೀಟ್ ಇದ್ರ ಮೇಲೆ. ಸೊ ವಾಟ್ ಎವರ್ ಅಟ್ ದ ಎಂಡ್ ಆಫ್ ದಟ್ ಕಾಲಮ್ ನಿಮ್ ಲೆಸ್ ಲೈಕ್ ಯುವರ್ ಬ್ಯೂರೇಟ್ ಅಟ್ ದ ಎಂಡ್ ಆಫ್ ದಟ್ ಇದು ನಿಮಗೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಪ್ಯೂರಿಫೈಡ್ ಸೊಲ್ಯೂಷನ್ ಸಿಗ್ತದ. ಇಂಪ್ಯೂರಿಟಿ ಏನೇನ್ ಇರ್ತದಲ್ಲ ಆ ಕಾಲಮ್ ದೊಳಗನೆ ಕೂತ್ ಬಿಡ್ತದ. ಅದು ಪ್ಯೂರಿಫೈಡ್ ಏನಿರ್ತದಲ್ಲ, ಈಗ ನೀವ್ ಹೆಂಗ ಬ್ಯೂರೇಟ್ ನೋಡಿರಿ, ಯು ಪೀಪಲ್ ಆರ್ ವೆರಿ ಫ್ಯಾಮಿಲಿಯರ್ ವಿತ್ ಬ್ಯೂರೇಟ್. ಆ ಬ್ಯೂರೇಟ್ ದೊಳಗೆ ಅಬ್ಸಾರ್ಬೆಂಟ್ ಅಂತ ಸಿಗ್ತದ. ಓಕೆ, ಲೈಕ್ ಜಲ್ ಬರ್ತಾವ, ಸಿಲಿಕಾ ಜಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ ಜಲ್ ಹಾಕ್ತಿವಿ, ಕಾಲಮ್ ಫುಲ್ ಫಿಲ್ಅಪ್ ಮಾಡ್ತೀವಿ. ಆಮೇಲೆ ನಿಮ್ ಇಂಪ್ಯೂರ್ ಮೆಟಲ್ ಸೊಲ್ಯೂಷನ್ ಹಾಕ್ತಿವಿ, ಲೈಕ್ ಏನ್ ಹೇಳಿದ್ವಲ್ಲ ನಾವು ಬ್ರೈನ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಏನ್ ಹೇಳಿದ್ವಲ್ಲ ಆಗಾಳೆ. ಓಕೆ, ಜಸ್ಟ್ ಇಟ್ ಇಸ್ ಅ ಸಿಂಪಲ್ ಅಕ್ವಿಯಸ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ದ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಸೊಲ್ಯೂಷನ್. ಅದನ್ನ ಹಾಕಿದಾದ್ಮೇಲೆ ಎಲ್ಲಾ ಸೋಡಿಯಂ ಮೆಟಲ್ ಇಂಪ್ಯೂರಿಟಿ ಎಲ್ಲ ಆ ಇದ್ರೊಳಗೇನೆ ಕಲೆಕ್ಟ್ ಆಗಿ ಕೂತ್ಬಿಡ್ತದೆ, ಕಾಲಮ್ದಾಗನೆ ಕೂತ್ಬಿಡ್ತದೆ. ಪ್ಯೂರ್ ಕ್ಲೋರಿನ್ ಅಷ್ಟೇ ಕೆಳಗಡೆ ಬರ್ತದೆ, ಕ್ಲೋರಿನ್ ಅಯಾನ್ಸ್ ವಿತ್ ಕ್ಲೋರಿನ್ ಅಯಾನ್ಸ್. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ ಥಿಂಗ್ ವಿ ಕ್ಯಾನ್ ಕಮ್ ಅಕ್ರಾಸ್ ಪ್ಯೂರಿಫಿಕೇಶನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ. ಸೇಮ್ ಅದ್ರಾಗೇನೆ ಮತ್ತೆ ಬೇರೆ ಬೇರೆ ಥಿನ್ ಲೇಯರ್ ಕ್ರೋಮೆಟೋಗ್ರಫಿ, ಪೇಪರ್ ಕ್ರೋಮೆಟೋಗ್ರಫಿ, ಗ್ಯಾಸ್ ಕ್ರೋಮೆಟೋಗ್ರಫಿ ಅಂತ ಬೇರೆ ಬೇರೆ ಕ್ರೋಮೆಟೋಗ್ರಾಫಿಕ್ ಟೆಕ್ನಿಕ್ಸ್ ಅವ. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ ಥಿಂಗ್. ಓಕೆ, ಇಟ್ಸ್ ರೈಟ್ ನೌ ಆಲ್ರೆಡಿ 9:11. ಜಸ್ಟ್ 33 ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಆರ್ ದೇರ್. ಟೈಮ್ ಆಯ್ತಪ್ಪ ಅಂದ್ರೆ ನಿಮ್ಮಷ್ಟಿಗೆ ನೀವೇ ಪರ್ಮಿಷನ್ ತಗೊಂಡ್ಬಿಡ್ತೀರ ಕ್ಲಾಸ್ ಬಿಟ್ಟು ಹೋಗೋದು. ದಟ್ ಇಸ್ ಅ ಲೆಫ್ಟ್ ಆನ್ ಯು ಪೀಪಲ್ಸ್ ಕಂಪ್ಲೀಟ್ಲಿ. ದಟ್ ವಿಲ್ ಬಿ lost to you only. So this completes your isolation of elements. Totally hope so. ಇದು ಕಂಪ್ಲೀಟ್ ಆದ್ರೆ ಸಾಲಿಡ್ ಮುಗೀತು, ಸೊಲ್ಯೂಷನ್ ಮುಗೀತು. ಹೌದಾ? ಸಾಲಿಡ್ ಮುಗೀತ್ರಿ, ಸೊಲ್ಯೂಷನ್ ಮುಗೀತು, ಮತ್ತೆ ಸರ್ಫೇಸ್ ಕೆಮಿಸ್ಟ್ರಿ ಮುಗೀತು, ಐಸೋಲೇಷನ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸ್ ಮುಗೀತು. So totally 4 chapters has been get completed. Sir is right now dealing their chemical kinetics. Similarly, we will move towards the next chapter in the upcoming class. Okay. Thank you. Mohan sir.
Yes, sir. Send you, sir.
Who is that, Ayub? Hopeless fellow.